Ben & Jerry's is pumped out of factories by the ton, faster, colder, and creamier than you'd ever expect. From giant mixers churning out rich bases to cookie dough and brownie chunks being dropped with precision, every pint is a factory-engineered dessert. In this video, we're diving inside the delicious chaos of how Ben & Jerry's is really made. The story of how Ben & Jerry's ice cream is made begins long before anything is frozen. It starts on dairy farms. Like any premium ice cream, Ben & Jerry's uses high butterfat cream and milk, generally sourced from cooperative dairy farms within a tight radius of its production plants. The base mix includes fresh milk, heavy cream, and liquid sugar, which are delivered to the plant in insulated tanker trucks. These raw materials must meet stringent specifications for fat content, microbial load, and traceability, and are tested upon arrival before entering production. Once cleared, these ingredients are pumped into blending tanks, massive stainless steel vessels fitted with temperature control jackets and agitation systems. Here, milk and cream are mixed with liquid sugar, egg yolks or pasteurized egg mix, and stabilizers like guar gum or carrageenan, which help improve body and texture and prevent ice crystal formation during freezing and storage. At this point, you have what's called the ice cream mix, still liquid, still unflavored, and not yet pasteurized. The next step is critical: pasteurization. The mix is pumped through a high-temperature, short-time pasteurizer, a system of tubular heat exchangers that rapidly heats the liquid to about 82 degrees C and holds it there for around 25 seconds before cooling it down immediately. This process kills off pathogenic microbes and reduces spoilage organisms without compromising the mix's functional proteins and sugars. As the liquid exits pasteurization, it's routed to homogenizers, where the fat particles are mechanically reduced in size and dispersed uniformly throughout the mix. This prevents fat separation and contributes to the smooth mouthfeel consumers expect from premium ice cream. Ben & Jerry's typically targets a butterfat content of around 14 to 16%, significantly higher than standard commercial ice cream, which gives their products their rich, dense texture. From here, the mix is sent to aging tanks, where it rests for several hours, usually 4 to 8 hours, at a chilled temperature of around 4 degrees C. This aging process allows the fat globules to crystallize slightly and the proteins and stabilizers to fully hydrate. The result is a thicker, more stable mix that is better suited for whipping and freezing during the next phases of production. Once aged, the mix is portioned and routed to one of multiple flavor vats, individual mixing tanks where the base ice cream mix is transformed into the beginnings of Cherry Garcia, chocolate chip cookie dough, fish food, and countless other signature flavors. This is where natural and artificial flavor extracts, cocoa powders, coffee concentrates, purees, or syrups are added depending on the recipe. Mixing times and speeds are carefully controlled to avoid over-aerating the mix or destabilizing emulsifiers. For chocolate-based flavors, melted or powdered chocolate may be folded into the mix. For fruit flavors, purees are added in a way that preserves acidity and color. At this point, the product still resembles a thick milkshake, flavored but not yet frozen. The next step is one of the most defining in ice cream manufacturing: dynamic freezing. The flavored mix is sent to a continuous freezer, a barrel-like machine lined with a refrigerated cylinder and a rotating scraper blade. The mix enters the freezer at 4 degrees C and is rapidly cooled to between 5 degrees C and 7 degrees C while being churned. The rotating blade scrapes frozen mix off the interior wall while simultaneously whipping air into the mixture. This whipping process is where overrun, the amount of air incorporated into ice cream, is controlled. Ben & Jerry's is known for its low overrun, typically 20-30%, meaning that only a small amount of air is introduced. This contrasts with cheaper ice cream brands that may reach 100% overrun or more, effectively doubling their volume with air. Low overrun results in a denser, creamier mouthfeel and more concentrated flavor. As the now partially frozen ice cream emerges from the continuous freezer, it's time for the brand's most iconic touch: the chunks and swirls. Whether it's brownies, cookie dough, peanut butter cups, cherries, caramel ribbons, marshmallow swirls, or crushed pretzels. These inclusions are added through ingredient feeders positioned immediately after the freezer. These feeders are synchronized to the output flow of the freezer, metering in the exact amount of mix-ins per liter of ice cream. Chunks are usually pre-portioned and frozen before use to ensure they hold their shape and don't smear during incorporation. Swirls like caramel, fudge, or raspberry are often delivered through variegating pumps, which inject thin streams of the sauce into the ice cream flow, creating marbled ribbons without complete mixing. At this stage, the ice cream is still semi-soft, similar to soft serve. It's immediately deposited into pint containers using rotary filling machines. These fillers can dispense precise volumes of chunky, semi-frozen ice cream into containers at high speed, while maintaining uniformity of fill, swirl distribution, and mix-in density. Some production lines may have multiple fillers operating in parallel to support different flavor runs. After filling, the containers pass through lid applicators, which press fit the branded plastic or paperboard lid onto the pint. Immediately afterward, the sealed pints enter a spiral hardening tunnel, a vertical or horizontal freezer where the product is rapidly cooled to 25 degrees Celsius or lower. This quick hardening step locks in air cell structure, prevents mix-in movement, and helps stabilize the final texture. As the freshly filled and lidded pints move into the hardening tunnel, they begin what is arguably one of the most critical transitions in the entire process, from semi-frozen to fully stable, deep frozen product. These tunnels, either spiral or straight line, are engineered cold zones where sub-zero air circulates with force around each pint to rapidly extract residual heat. The goal is to bring the core of the product down to 25 degrees Celsius or colder in under an hour. This rapid freezing is essential for two main reasons. First, it halts the migration of air bubbles and inclusions, preserving the pint's structural integrity. Second, it minimizes the growth of large ice crystals, which are the enemy of smooth texture in ice cream. If the freezing occurs too slowly, moisture migrates toward larger ice nucleation sites, forming gritty textures and compromising creaminess. Ben & Jerry's combats this with state-of-the-art airflow management, freezing plate design, and strategically placed airflow vents to ensure each pint freezes evenly. Once hardened, the pints exit the tunnel and travel via stainless steel conveyors to the labeling and inspection zone. Here, a multi-stage packaging line ensures that each pint is correctly dressed for store shelves. First, shrink-wrapped tamper bands are applied around the lid and container seam. These bands are heat shrunk using a tunnel fitted with infrared heaters or warm air jets, ensuring a snug, tamper-evident seal without damaging the container. After banding, the pints pass through labeling machines. These units apply pre-printed labels that identify the flavor, ingredients, nutritional information, and UPC codes. The labels are typically made from moisture-resistant paper or plastic film, designed to withstand freezer condensation without curling or peeling. For special edition flavors or collaborative launches, like their music or movie tie-ins, custom labels may feature additional artwork, QR codes, or collector designs. Next in line is date coding and traceability stamping. High-speed inkjet printers mark each pint with a unique combination of batch number, production date, plant code, and expiration or best by date. These identifiers are not just for consumers, they're crucial for traceability. In the event of a recall or a customer quality complaint, these codes allow factory teams to pinpoint the exact mix batch, inclusion batch, production shift, and even the machine settings that created the pint in question. The fully finished pints now head to automated case packing stations. Here, robotic arms or pneumatic packers group pints, usually in batches of 8, 12, or 16, into corrugated cardboard cases lined with insulation. The case is formed, filled, sealed, and coded for logistics tracking. In some factories, these cases are palletized by robotic arms fitted with vacuum grippers or soft clamping systems designed to handle frozen goods gently but efficiently. Before the pallets head to cold storage, Ben & Jerry's applies a final layer of quality assurance sampling. At this stage, QA technicians pull random pints from the line and perform multiple tests, visual inspection, hardness checks, inclusion distribution, and even weight verification to ensure filling accuracy. In parallel, microbiological sampling is performed in nearby labs, where swabs from equipment and mixed samples are incubated and tested for pathogens like Listeria monocytogenes, Salmonella, or coliforms. For texture testing, QA teams use penetration testers or texture analyzers that simulate spooning or scooping action. These devices apply force to the pint and record resistance levels, ensuring that the ice cream isn't too hard, too soft, or inconsistently frozen. Flavor samples are stored for shelf life studies, while some are evaluated immediately in sensory booths by trained flavor panels. These panelists use calibrated scoring systems to check for balance, aroma, off flavors, and inclusion integrity. Approved pallets are then transferred to cold storage warehouses, gigantic freezer zones kept at 28 degrees or lower. These freezers often operate as high bay ASRS, with robotic cranes and elevators placing pallets into assigned positions tracked by warehouse management software. Each lot is tagged for first in, first out rotation, ensuring that older product ships before newer stock. From here, logistics takes over. Pallets are loaded into refrigerated trailers or intermodal freezer containers, known in the industry as reefers. These vehicles are temperature monitored and often GPS tracked to ensure no breach in the cold chain during transit. Depending on the destination, pints may go to national distribution centers, regional grocery chain warehouses, or direct-to-retail delivery hubs. Throughout this process, data is king. Every point in the production journey, from ingredient receipt to pallet shipping, is recorded digitally through an integrated MES. This data is critical, not just for traceability, but for continuous improvement. If a batch of brownies in chocolate fudge brownie was overly dry, or the caramel swirl in salted caramel core separated in freezing, plant managers can pull up historical temperature records, ingredient batch logs, and operator notes to identify and fix the issue in real time. Equally important are the company's ethics and sustainability commitments, which are interwoven into every level of the production process. Ben & Jerry's has long championed fair trade certified ingredients, which means the sugar, cocoa, vanilla, and even some fruits used in the recipes are sourced from cooperatives that meet specific labor and environmental standards. Contracts are long-term and include a premium above market price to support community development in origin countries. The brand also insists on using non-GMO ingredients and has pledged to phase out ingredients from suppliers who do not meet animal welfare or organic transition standards. This introduces added complexity into the procurement and manufacturing process. Ingredient traceability becomes more than just regulatory. It's also philosophical. Every inclusion, from cookie dough bits to marshmallow swirls, must be sourced from partners who meet strict social and environmental criteria. Even the dairy supply chain is managed under this ethical lens. While Ben & Jerry's doesn't own the farms that supply its milk and cream, it maintains close partnerships with co-ops that follow the Caring Dairy program, a sustainability framework that rewards environmentally responsible farming practices, cow health, and fair labor conditions. Farmers in the program agree to regular audits and continuous improvement plans, and many receive bonuses for reaching sustainability benchmarks. Inside the factories, waste reduction and resource efficiency are equally important. For instance, imperfect pints, those with air pockets, underfills, or swirl defects, are often diverted to food banks when safe and legal to do so. Others are reprocessed as animal feed, or, in the case of dairy-rich waste, diverted to anaerobic digesters that produce biogas. Rinse water from cleaning in-place systems is filtered and reused where allowed, and energy from high-load equipment like freezers and compressors is recovered for use elsewhere in the plant. Beyond its physical ingredients and cold chain logistics, Ben & Jerry's is perhaps best known for its bold, often unconventional flavors. But these don't come from a corporate flavor committee or boardroom marketing brainstorm. They're born in a real, functioning test kitchen that sits just a few hundred feet from the main production floor at the company's original facility. Inside this scaled-down version of the factory, small batch experimental runs are constantly in development. This pilot plant mirrors the equipment and flow of full-scale production, but is designed to work with batches as small as 50 liters. It includes a pasteurizer, homogenizer, flavor tanks, freezers, chunk feeders, and a hardening cabinet, allowing Ben & Jerry's to test everything from new core technologies to texture innovations, swirl viscosity, or chunk dispersal mechanics. The team working here includes food scientists, culinary professionals, sensory experts, and brand creatives. They call themselves the flavor gurus. Each new idea starts with a concept brief, a single paragraph of inspiration. It might be rooted in nostalgia, social themes, dessert trends, pop culture, or collaboration. From Netflix and chilled to Boom Chocolata, each flavor is more than a taste. It's a story. These concepts are often created through collaboration with artists, entertainers, non-profits, or grassroots campaigns. That story drives the flavor construction, down to the specific balance of salty and sweet, or the inclusion of unexpected textures. In the kitchen, development starts with ingredient feasibility. For instance, if a concept involves caramel popcorn clusters, the team must determine whether those clusters can hold up to the freezing and hardening process. Will they stay crunchy? Will they absorb moisture and turn gummy? What coating could act as a moisture barrier? These questions are addressed with bench trials using test batches of ingredients, freezing cycles, and controlled scooping tests. Inclusions are sourced from trusted suppliers who are usually part of long-standing relationships. The cookie dough, for example, is made by a bakery that crafts it specifically for Ben & Jerry's. Without eggs, for safe consumption straight from the pint. Brownies come from a social enterprise bakery that supports formerly incarcerated individuals. And chocolate chips, fudge chunks, and sandwich cookies are designed not just for taste, but to retain crunch or softness at sub-zero temperatures. Once a test batch is ready, it's subjected to sensory panel evaluation, both internally and through consumer testing. Internal testers are trained to evaluate sweetness perception, fat feel, aroma, flavor impact, inclusion dispersion, and swirl distribution. A successful flavor must score high on not just taste, but scoopability, mouth adventure, and flavor payoff. All are key sensory terms used inside the company to define the Ben & Jerry's experience. Consumer panels are equally important. These are conducted either on-site in branded scoop shops or via blind taste tests in neutral settings. Feedback is gathered on a range of metrics, including first impression, spoon texture, chunk ratio, and emotional response. A successful test doesn't just please, it delights. It might surprise or make someone laugh. Ben & Jerry's believes strongly in food as an emotional and political act, so flavors are not chosen based on margin or mass appeal alone. A flavor must reflect the brand's personality. When a concept graduates from test kitchen to factory line, it must be scaled up. This is not a simple multiplication of ingredients. Chocolate ripple patterns, for example, that look elegant in a 5-liter batch might smear or clump at industrial speeds. Chunk feeders that work flawlessly with peanut butter cups may jam with sticky cookie clusters. Every detail is re-engineered by the process development team to scale ingredients, maintain sensory profiles, and ensure food safety. Scaling up also includes global compliance. A flavor destined for international release must comply with food labeling laws, allergen declarations, and additive restrictions in each country. Colors and flavors allowed in the US may not be permitted in the EU or Canada. Sweetness levels may also need to be adjusted to meet regional expectations. Asian markets tend to prefer less sweet profiles, while North American consumers gravitate toward indulgence. Once scaled, the new flavor joins the official production schedule, either as a limited batch for seasonal or campaign-based flavors, or as a core line flavor, which receives permanent placement in production planning and freezer shelf space. The label design is finalized by the in-house creative team, complete with playful illustrations, bold typography, and often a brief blurb about the flavor's origin or cause affiliation. Labeling is more than decoration. Ben & Jerry's pints act as miniature billboards for social change. Many containers highlight issues like climate justice, LGBTQ+ rights, voting access, or racial equity. The flavor Change is Brewing, for example, was developed in partnership with grassroots organizers to promote racial equity in policing. Its back label didn't just list ingredients, it encouraged civic engagement. From concept to consumer, every step is infused with purpose, and that includes how the company manages customer feedback. Ben & Jerry's has a dedicated consumer affairs team that tracks comments, complaints, praise, and flavor suggestions. Every email, social post, or call is logged into a system that allows trend mapping over time. If a particular flavor receives recurring complaints, like chocolate chunks sinking or caramel being too sticky, those comments are flagged and routed back to R&D and production. In some cases, flavors are discontinued despite fan protests, not due to poor sales, but because ingredient sourcing became unsustainable or certain suppliers went out of specification. In other instances, flavors are brought back by popular demand. This is how the Flavor Graveyard was born, a real attraction at the Vermont headquarters, where tombstones commemorate flavors that came and went, often with witty epitaphs. It's both a marketing concept and a living archive of flavor evolution. New products also go through intense logistical modeling. A flavor with large, delicate chunks may reduce throughput on the filling line, increasing downtime or scrap rates. Swirls that require multiple variegate pumps increase mechanical complexity. These elements are balanced against forecasted demand, freezer slot availability at retailers, and even shipping temperature risk during peak seasons. That's why every pint of Ben & Jerry's you see on a store shelf represents not just a recipe, but an intersection of ingredient science, brand storytelling, community values, and mechanical precision. It's the result of hundreds of decision points, most invisible to the average consumer, but essential to maintaining the brand's reputation for quality, flavor, and integrity. As the pints are filled, hardened, labeled, and boxed, the next area of focus becomes how they travel through the supply chain and ultimately arrive in a consumer's freezer, intact, safe, and delicious. But beyond logistical coordination, Ben & Jerry's invests significant energy into one final yet incredibly important layer of manufacturing: packaging innovation. The iconic Ben & Jerry's pint is more than just a paperboard container. It's a temperature-resistant, freezer-tolerant, moisture-shielding package designed specifically for the product's density and texture. The container walls are made of a specialized coated paperboard lined with food-safe barrier films that resist freezer burn, moisture ingress, and cracking under ultra-low temperatures. The inside coating is formulated to prevent fat migration, a condition where lipids from the cream leach into the packaging over time, causing off flavors. The lid, typically made from HDPE or polypropylene plastic, snaps securely in place to prevent air exchange while still being easy to remove after hard freezing. For pints shipped internationally or stored long-term, an optional foil heat seal membrane is applied just beneath the lid. This creates an oxygen-impermeable barrier and protects against tampering or lid displacement during distribution. But just as important as performance is sustainability. Ben & Jerry's has made firm commitments to reducing their environmental footprint through packaging design. A major focus has been sourcing FSC-certified paperboard and increasing the recyclability of their containers. Though paperboard is technically recyclable, the inner lining poses challenges for municipal recycling systems. To combat this, the company has invested in trials using plant-based biopolymer coatings instead of petroleum-derived films, aiming to maintain moisture resistance while allowing better biodegradability or compostability in the future. Even the ink used on the labels has undergone scrutiny. Soy-based inks and water-based adhesives have become the standard, reducing reliance on volatile organic compounds during printing. For larger tubs used in scoop shops or food service formats, Ben & Jerry's is transitioning toward reusable, closed-loop options that can be collected, sanitized, and reissued where regional infrastructure allows. Still, the environmental impact of ice cream production extends beyond packaging. Frozen distribution is energy-intensive, requiring constant cold chain integrity from the moment the pint exits the hardening tunnel to the second it's unpacked at a grocery store. To mitigate this, Ben & Jerry's distribution partners invest in high-efficiency freezer trucks, refrigerated warehouses with thermal insulation, and solar-assisted energy offsets where possible. Some logistics centers use CO2-based refrigeration systems, which have a significantly lower environmental impact than traditional hydrofluorocarbon refrigerants. Pints destined for export are packed in refrigerated intermodal containers and transported via rail or ship to reduce carbon emissions. Temperature is monitored in real time, and alerts are sent if any container rises above the critical 18 degrees C threshold. Any thermal excursions during transit are flagged, and affected product is either returned or discarded, depending on severity. There's no compromise on quality. Once pints reach their retail destinations, whether big box stores, co-ops, gas stations, or independent grocers, they are unpacked and placed in open-top commercial freezers designed to hold temperatures consistently and ensure visibility of the brand. Ben & Jerry's also monitors in-store freezer environments through data loggers placed in select markets. These devices measure temperature trends and help identify retailers where the product may be exposed to excessive fluctuation, leading to texture degradation or shrinkage. At this stage, freezer-to-spoon performance becomes critical. Unlike low-fat or high-air ice creams that soften quickly, Ben & Jerry's ultra-premium product is dense, full-fat, and low overrun, making it slower to thaw. Engineers have worked to balance the pint's firmness with scoopability by optimizing the ratios of milk solids, sugars, and fats. Stabilizers like Gar Gum and Locust Bean Gum help create an ice matrix that resists shrinkage while softening gradually and predictably. Sensory testing even includes wait time analysis, a timed metric that captures how long a pint must sit at room temperature before it reaches ideal scoopability. The goal is to strike a balance, long enough to preserve freezer life, but not so hard that consumers become frustrated waiting to eat it. Recent innovations have included small adjustments in fat globule size and emulsifier use to reduce the scoop delay by up to 30 seconds without compromising the iconic creamy mouthfeel. What's remarkable is how all of these technical, logistical, and quality-driven steps still connect directly back to the brand's identity. Ben & Jerry's isn't simply a company that produces ice cream. It's a brand built on progressive values, social action, and vocal advocacy, an uncommon stance in a heavily commoditized food industry. From their earliest days in Vermont, the founders saw the company as a platform for community building and systemic change. That mission continues today, even under the ownership of a global conglomerate, through an internal, values-led sourcing program, a public social mission statement, and a justice team that works full-time on partnerships and advocacy campaigns. That means the company is as likely to issue a statement on voting rights or environmental justice as it is to release a new flavor. These values don't just live in press releases, they manifest in the factories too. Production workers participate in community volunteer programs and receive above-market wages. Ingredient sourcing contracts include equity clauses and social premiums. And flavors are routinely used as tools for storytelling. Empower Mint was developed to promote voting access in marginalized communities. Save Our Swirled drew attention to the climate crisis. Home Sweet Honeycomb highlighted the plight of refugees. The production of a Mars bar begins with the formulation and creation of its first major internal layer, the nougat. This nougat isn't the brittle kind you might find in traditional nut candies. Rather, it's a whipped, creamy, slightly chewy foundation that gives Mars bars their signature texture. Creating this nougat at industrial scale is a carefully engineered process that blends confectionery science with mass production machinery and strict environmental controls. Before the first batch of nougat is made, however, the ingredients themselves must be prepared and stored according to strict protocols. The base ingredients for the nougat are sugar, glucose syrup, water, fat typically palm or shea oil, dried milk powder, cocoa powder, and whipped egg white or egg albumin. All these materials arrive at the Mars manufacturing facility in bulk, delivered in tankers, tote bags, or sealed sacks. Each delivery is logged, barcoded, and entered into the site's inventory system. But before any ingredient enters production, it must pass Mars' internal quality standards. All dry ingredients, such as sugar and milk powder, are transferred into enclosed silo systems using pneumatic conveyors. These silos are climate-controlled and fitted with HEPA filtration to prevent contamination from dust or ambient air. Each ingredient batch is tagged with a barcode that traces it back to its supplier, production date, and previous storage conditions. For example, sugar may be tested for grain size, purity, and color using laser granulometry and ICUMSA color unit analysis. If it's outside tolerance, it's rejected immediately. Liquid ingredients like glucose syrup and oils are offloaded into jacketed stainless steel storage tanks through filtered, food-grade hoses. These tanks maintain the ingredients at set temperatures to ensure proper viscosity for pumping during production. Glucose syrup, for instance, is kept at around 40 degrees Celsius to remain fluid enough to move through piping without crystallizing. Oils are similarly heated and agitated to prevent separation or solidification. Once all components have been approved and staged, the first step in actual nougat production begins in a dedicated mixing chamber. This space is sealed off from other parts of the factory and maintained at specific humidity and temperature levels to preserve the quality and structure of the aerated product. Airborne particles are filtered through a multi-stage air filtration system, and stainless steel surfaces are sanitized before each production run. Nougat is made in large capacity continuous mixers, automated machines that blend ingredients while precisely managing flow rate, temperature, and mixing speed. In a traditional batch process, workers would mix sugar and glucose syrup with water and cook it to a specific temperature. But in Mars's high-speed factories, this process is carried out on a continuous flow basis, meaning raw ingredients are metered into the cooking system in real time, mixed, cooked, and then aerated in a constant stream. First, sugar, glucose syrup, and water are combined in a jacketed mixing vessel and brought up to temperature using indirect steam heating. The mixture must reach roughly 115 to 120 degrees Celsius, hot enough to dissolve all solids and achieve the correct consistency for whipping, but not so hot that caramelization occurs. Inline refractometers monitor the Brix level, sugar concentration, constantly, sending digital signals to a control system that adjusts syrup feed rate or cooking temperature as needed to stay within spec. Once the syrup reaches target temperature and concentration, it's transferred to a cooling chamber, where it's rapidly brought down to around 70 to 80 degrees Celsius using chilled water jackets. This temperature reduction is critical. It stabilizes the syrup mixture and prepares it for aeration with egg whites or albumin, which cannot be added while the base is too hot without denaturing the proteins. Now comes the aeration stage, where the characteristic lightness and chew of the nougat is created. A pre-prepared egg albumin solution is metered into the cooled sugar syrup in a continuous aerator. This machine functions much like a planetary mixer, but at vastly greater speed and scale. Blades spin at extremely high RPMs inside a sealed chamber, while air is injected under pressure. The result is a fluffy, stable foam that has the volume and consistency of whipped marshmallow. The air injected into the aerator is sterile and dry, supplied by an inline compressed air system equipped with microbial filters and dehumidifiers. Pressure, temperature, and air-to-liquid ratio are all controlled automatically via programmable logic controllers, PLCs, which adjust mixing speed and flow rate to maintain uniform aeration. If the density of the nougat mixture falls outside of target specifications, measured by inline densitometers, the system automatically corrects the air or syrup flow or alerts operators to intervene. At this point, cocoa powder and dried milk are added to the base. These ingredients give Mars Bar Nougat its unique color and rich malted taste. They are added using powder feeders that continuously meter the dry materials into the aerated mass as it exits the mixer. This blending occurs in a sealed paddle mixer with gentle, controlled agitation to avoid collapsing the foam structure. The resulting mixture is a warm, chocolatey nougat paste with a light, stable structure and a semi-elastic texture. Now that the nougat base is formed, it must be shaped and cooled. The nougat flows out of the mixer onto a stainless steel conveyor belt, forming a continuous slab about 2 to 3 centimeters thick. This slab passes through a chilling tunnel, where it is gradually cooled from around 60 degrees Celsius to just below ambient temperature. The tunnel uses recirculated cold air, zoned in multiple sections, to cool the nougat evenly without inducing condensation or hardening the outer surface too quickly. As the slab exits the chilling tunnel, it enters a cutting station. Rotary guillotine knives, synchronized with the belt speed, slice the slab crosswise into narrow ribbons, each of which will become the base layer of a Mars bar. These ribbons are then cut lengthwise by inline blades or ultrasonic cutters, creating rectangular nougat centers of uniform size. Every bar section is scanned by vision systems to check for dimensional consistency, length, width, and height, with auto-reject mechanisms removing any pieces that fall outside tolerance. The formed nougat segments are now ready to receive their second major component, the caramel layer. But before caramel is deposited, the nougat sections are spaced and aligned using lane diverters and product guides, ensuring that each bar proceeds uniformly through the next phase of production. The segments then pass into a buffer zone where their temperature is stabilized to prepare for caramel application. Now that the nougat segments are cooled, cut to precise dimensions, and cued in alignment on the conveyor system, the next phase in the Mars chocolate bar manufacturing process begins: the production and deposition of the caramel layer. This caramel is not a generic topping, it's one of the signature components that defines the textural and flavor contrast of a Mars bar. Creating this layer at scale requires a specialized process that integrates continuous cooking, emulsification, temperature control, and precision depositing, all engineered to work seamlessly within the speed and flow of a high-volume confectionery production line. The caramel used in Mars bars is made from a carefully balanced combination of sugar, glucose syrup, sweetened condensed milk or milk solids, and a specific blend of fats and emulsifiers. It's cooked to achieve a particular consistency, not too firm, not too runny, with a creamy chew that holds its shape during wrapping and storage, yet yields easily when bitten into. The production of caramel begins in a dedicated cooking area, separate from the nougat line, but synchronized with it to maintain constant throughput. All ingredients are stored in bulk near the cooking zone. Sugar and milk powders are gravity-fed from silos into high-shear premixes, while glucose syrup and fat are pumped in from temperature-controlled tanks. The emulsifiers, such as mono and diglycerides, are introduced through metering pumps in very small, tightly controlled amounts to help ensure smooth texture and fat water dispersion. A water phase may also be introduced at the start to aid in initial dissolution and prevent localized overheating. The entire mixture is first blended in a jacketed stainless steel preheating tank, where it's brought to a uniform temperature of around 70 to 80 degrees Celsius. This pre-cooking stage ensures that all ingredients are fully homogenized before entering the main caramel cooker. From here, the caramel mix is pumped continuously into a vacuum caramel cooker, a specialized machine that allows rapid, even heating while removing excess water to control the final solid's content and viscosity. Vacuum caramel cookers work by reducing the internal pressure in the cooking chamber so that water boils off at a lower temperature. This is crucial to avoid burning the sugars or overcooking the milk solids, which could lead to bitter notes or textural instability. Inside the cooker, the mix is heated to between 115 degrees Celsius and 120 degrees Celsius. The target is to achieve a final water content of around 6 to 8%, with a sugar concentration of roughly 80 to 85 bricks. Inline refractometers monitor this constantly, and the cooker adjusts residence time or heating level as needed to meet the spec. Once cooked, the caramel exits the cooker as a thick, glossy liquid with a rich golden brown hue. But before it can be applied to the nougat, it must be slightly cooled and tempered to a very specific range, typically between 45 degrees Celsius and 55 degrees Celsius. This cooling step stabilizes the caramel structure, allowing it to flow evenly during deposition without dripping or bleeding into the nougat layer. Cooling is performed in a jacketed holding tank equipped with slow-speed agitators that prevent crusting and keep the mixture homogeneous. With the caramel at the correct temperature, it's piped toward the depositing station. Here, the aligned nougat segments are conveyed under a continuous curtain-style depositor or a series of timed nozzles. Each piece receives a uniform layer of caramel, typically around 5 to 6 millimeters thick, depending on the final product specification. The depositor is precisely synchronized with the line speed, often using servo motors and optical sensors, so that each caramel stream lands squarely on the nougat block without overflow or excess. In higher speed lines, a pre-formed caramel sheet may be used instead. In this method, caramel is spread onto a separate cooling belt, allowed to set into a thin slab, and then laminated onto the nougat in one continuous motion using compression rollers. This technique allows better layer thickness control at very high production speeds and ensures cleaner edges for slicing. Once the caramel is applied, the dual layer bar now enters another cooling tunnel, usually a multi-zone refrigerated belt system that brings the caramel from 50 degrees Celsius down to just under 20 degrees Celsius. This cooling step must be gradual and controlled. Too rapid, and the caramel may contract unevenly, leading to separation from the nougat. Too slow, and it may remain sticky, interfering with the next step. Chocolate enrobing. During cooling, the layered bar is gently compressed by a roller to ensure adhesion between nougat and caramel. Then, it's passed through edge trimmers, which shave off the sides of the slab to produce perfectly square bars with clean, vertical sides. These trimmed edges are not wasted. They are collected via vacuum conveyors and reprocessed, either remelted or reformed, depending on factory protocol. The bar, now comprised of a cooled nougat base and a bonded caramel layer, is next cut into individual pieces using high-speed guillotine cutters. These are precision machines equipped with hardened stainless steel blades or ultrasonic cutting systems that minimize drag and preserve edge integrity. Each piece is exactly the length and width of a finished Mars bar, around 10 centimeters long and weighing roughly 51 to 57 grams, depending on the market. As the bars are cut, they are spaced out evenly using puck conveyors or lane dividers, aligning them perfectly for entry into the chocolate enrobing section. The temperature, moisture, and dimensional uniformity of each bar are verified by inline sensors and vision systems. Bars that are cracked, too short, or unevenly shaped are automatically diverted off the line for manual inspection or rework. At this stage, we transition into the enrobing process, the iconic step where each bar is coated in a smooth layer of Mars proprietary milk chocolate blend. This chocolate is stored in large tempering tanks, located just prior to the enrober. These tanks keep the chocolate at the ideal crystallization state, ensuring a glossy finish and firm snap after cooling. The chocolate used in Mars bars is a blend of cocoa liquor, cocoa butter, sugar, and milk solids, with added emulsifiers like soy lecithin to enhance flow properties. The tempered chocolate is pumped into the enrober, which is essentially a tunnel lined with a bottoming section to coat the base of each bar, and a curtain section to drape chocolate over the top and sides. Each Mars bar passes first over a shallow pool of chocolate to coat its underside, then directly beneath a flowing curtain that envelops the rest of the bar. A gentle stream of warm air is directed across the top to remove excess and create a rippled surface texture, a distinctive feature of the Mars bar. After enrobing, the bars are conveyed into the cooling tunnel, an extended refrigerated belt system approximately 20 to 30 meters in length. Inside, the environment is segmented into zones that gradually lower the temperature of the bars from around 32 degrees Celsius to 10 degrees Celsius. This staged cooling helps the cocoa butter in the chocolate crystallize properly, locking in the sheen and texture while avoiding fat bloom or streaks. Throughout this tunnel, air humidity is tightly controlled, generally under 50%, to prevent condensation on the chocolate. Dew point sensors and fans work in tandem with the refrigeration units to maintain a stable microclimate. The bars spend 5 to 8 minutes in this tunnel before emerging with fully set coatings, ready for packaging. As the cooled and finished bars exit the tunnel, they're fed into accumulation conveyors and grouped for wrapping. Each bar passes through a flow wrapping machine where printed film is unwound, formed into a sleeve, and sealed around the product. The wrapper is then crimp sealed on both ends and trimmed. These wrapping machines can process hundreds of bars per minute, and each wrapped bar is weighed and scanned before being discharged onto final packing belts. At this point, the product is visually indistinguishable from the Mars bar found on store shelves, but the process is still not finished. The next stage involves secondary packaging, grouping bars into boxes, cartons, and shipping trays, and preparing them for distribution. As the fully formed, enrobed, and cooled Mars bars make their way off the production line, they enter the final stages of the factory process, beginning with high-speed wrapping and continuing through automated boxing, palletization, storage, and outbound logistics. These downstream systems are critical not just for protection and presentation of the product, but also for ensuring traceability, quality retention, and supply chain synchronization. While the visible production, the mixing, cooking, cutting, and coating is complete, the final packaging and handling stages are no less intricate, built on robotics, data systems, and industrial automation designed to manage millions of units every day. The first stop is the wrapping station. Here, each Mars bar moves along the conveyor belt in single file toward the flow wrapping machine. This machine feeds a continuous roll of printed film into a series of folding arms and sealing jaws. As each bar enters, the film wraps around it in a tight, tubular sleeve, and heated crimp jaws at either end form the back seal and the end seals simultaneously. The temperature of these jaws is maintained within a few degrees of the sealing material's activation point to ensure strong, clean closures without melting or burning the film. Mars uses multi-layered packaging films that are designed not only to provide barrier protection against oxygen and moisture, but also to deliver the tactile feel and gloss that customers expect from premium chocolate packaging. The inner layer is typically a heat-sealable polymer. The middle layer may include aluminum or metallized PET for barrier properties. And the outer layer is printed with brand artwork and product information. The printed designs are registered with high-precision sensors, so every bar's logo aligns perfectly. Any misregistered wrapper is automatically detected and rejected by an optical scanner system. Once sealed, the wrapped bar passes over a check weigher, an in-motion scale that ensures the final packaged weight is within tolerance. If a bar is over or underweight, even by a gram, it's automatically diverted. Next, each unit is passed under a metal detector, which checks for any possible foreign objects that could have entered the bar during earlier processing stages. These systems are highly sensitive and calibrated daily with test pieces. Some plants also employ X-ray machines that detect not just metal, but dense, non-metallic contaminants, such as glass or stone. Bars that pass all inspections continue down the conveyor toward the cartoning line. Depending on the intended retail format, bars may be grouped into multi-packs, retail-ready trays, or shipping cartons. Robotic arms or high-speed diverters organize the flow of individual bars into stacks, 4, 6, 10, or 12 bars wide, and gently push them into pre-folded cardboard sleeves or boxes. These secondary packages are then sealed using hot melt glue or tuck-in flaps, depending on market requirements. Each package receives a printed label with batch number, timestamp, factory ID, and possibly a QR code for inventory tracking. From here, boxed products are routed to the palletizing station. Robotic palletizers pick up full cases using vacuum grippers or mechanical arms and stack them on wooden or plastic pallets in precise formations. Each layer is arranged to optimize space, balance, and load stability. Between layers, some systems add cardboard slips or corner protectors for reinforcement. Once the pallet reaches its programmed height, typically 1.6 to 1.8 meters, it's wrapped in stretch film by an automatic wrapper, which rotates the pallet while dispensing the film under tension to secure the load. The wrapped pallets are then fitted with pallet labels that include the SKU, total unit count, gross weight, destination code, and a unique identifier that ties back to the factory's internal tracking system. These labels are printed by thermal printers and verified by barcode scanners before the pallets are cleared to enter the finished goods warehouse. Before we go further, it's important to recognize the role of Mars factory control systems in managing this entire post-production phase. All equipment is integrated into a centralized manufacturing execution system, MES, that tracks every product in real time. Each bar, box, and pallet carries data embedded in barcodes or RFID tags about when it was made, on which line, using which ingredients, and under what conditions. This traceability is a cornerstone of food safety compliance and internal quality assurance. The finished goods warehouse is where the newly palletized bars await shipment. This warehouse is fully climate controlled to maintain optimal temperature and humidity for chocolate storage. Temperature is held at 18 to 20 degrees Celsius with relative humidity below 55% to prevent bloom, melting, or texture changes. Air circulation systems keep temperature consistent throughout the space, while insulation and vapor barriers prevent external fluctuations from impacting internal conditions. Inventory in the warehouse is managed using automated guided vehicles, AGVs, or forklifts equipped with real-time location systems. When pallets are stored, they're scanned into the warehouse management system and placed according to distribution priority. High turnover products are stored closer to the shipping bays, while seasonal or export variants may be stored deeper in the racking system. The storage time for any batch is typically less than a week, as Mars factories operate on just-in-time logistics, pushing product out daily to meet distributor orders. When shipments are requested, the warehouse team receives a digital pick list. AGVs or operators retrieve the designated pallets, verify them via handheld scanners, and stage them at the outbound docks. Before loading, each shipment is inspected to ensure it matches the order specification, is within temperature tolerance, and has intact pallet wrapping. Refrigerated or climate-controlled trucks are often used for long-distance shipments or deliveries to regions with high ambient temperatures. Loading is done using dock levelers and roller systems to ensure smooth movement and prevent tipping. During transit, temperature loggers accompany the shipments, recording data at set intervals. These loggers are checked upon delivery, and if any deviation from the acceptable range is detected, the shipment may be flagged for inspection or rejection. Mars also monitors customer feedback, market audits, and in-store quality surveys. Samples of each production lot are retained in climate-controlled storage at the factory for shelf life testing. These retained samples are periodically tested for appearance, taste, texture, and microbiological stability over the course of months, ensuring that every production protocol performs as expected long after the product has left the plant. Parallel to all of this is a dedicated quality control laboratory. Here, daily production samples are subjected to physical and chemical analysis. Moisture content, fat content, sugar crystallinity, pH, and emulsion stability are checked using instruments like Carl Fisher titrators, differential scanning calorimeters, and viscometers. Sensory panels trained in Mars' specific flavor and texture profiles evaluate samples for aroma, mouthfeel, and aftertaste. Auditors regularly conduct surprise inspections, testing product against regulatory standards in every region the factory exports to. Some facilities even run accelerated aging chambers, simulating 6 months of shelf life in a few weeks using controlled temperature and humidity cycling. This allows the company to predict how new packaging or ingredient changes may impact long-term stability before releasing them to the market. Within the final layers of Mars' chocolate bar manufacturing process lies an often unseen yet deeply critical infrastructure dedicated to innovation, iteration, and global standardization. While the production lines are optimized for high-speed consistency, behind the scenes, the company operates pilot plants and R&D laboratories, where new formulations, production methods, and equipment calibrations are continuously tested, refined, and validated before they're deployed across global facilities. Every Mars chocolate bar, regardless of where it is produced, in the United States, the United Kingdom, or other licensed manufacturing hubs, must adhere to an extremely narrow window of variation. This means the bars must look, taste, feel, and behave identically, despite being produced in plants thousands of kilometers apart. Achieving this demands extensive process documentation, real-time data comparison, and coordinated updates to recipes and equipment settings across all sites. Pilot plants, often located adjacent to main production facilities, house miniature versions of the full-scale equipment, scaled-down mixers, depositors, tempering tanks, and enrobers, used not just for prototyping new flavors or bar formats, but also for stress testing ingredient substitutions, adjusting for new cocoa sources, or modifying emulsifier levels in response to regional ingredient availability or regulation. A new Mars bar variant, such as one with an added layer of cookie or a salted caramel flavor, may go through dozens of test batches before scaling. Each trial is evaluated not just for consumer preference, but for how it performs on actual equipment. Does the caramel spread at the correct rate on moving belts? Does it maintain form through the cooling tunnel? Does the chocolate enrobe correctly without altering crystallization time? These questions are answered with data from test runs that are digitally logged and used to generate predictive models before any large-scale production begins. Digital twins, virtual simulations of real production environments, are increasingly being used in these trials. These tools model fluid dynamics, thermal behavior, and mechanical stress on ingredients during cooking, cooling, and transport. They allow engineers to simulate a dozen line changes without touching a single piece of physical equipment, drastically accelerating the pace of safe innovation. Once a new process is approved, Mars' global standardization team prepares comprehensive change packs, which include updated process parameters, safety protocols, ingredient specs, equipment calibration charts, and software updates. These packs are then distributed to all regional manufacturing hubs, often followed by remote training sessions or on-site visits to ensure implementation is seamless. This global coordination ensures that whether you open a Mars bar in Chicago, Sydney, or Madrid, the experience is identical, down to the snap of the chocolate, the elasticity of the caramel, and the melt rate of the nougat. Let's begin with the fresh, clean meat carefully fed into the machine. ensuring it's boneless to avoid any processing issues. It's divided into portions to constantly send them into huge grinders bit by bit. This step-by-step approach guarantees that the meat is perfectly processed without any lumps, achieving perfection in every bite. As they choose to give the sausages a perfect blend and mouth-watering flavors, they work on the mixed meats, which involve frozen meat too. Just to inform you, freezing the meat at low temperatures for a specific duration kills parasites and bacteria, crucial for the safety of sausages. This process not only enhances their shape to perfection, but also extends the shelf life of these savory treats, giving them a smooth, buttery texture. You can see how beautifully the entire meat is shredded and chopped. Buckle up because it's going to be rich and smooth, just as you like. In the next step, a mix of spices or herbs is added for great flavor. It's all in the blend of spices and meats. Some are spicy with a kick of pepper, while others are mild, so they will cook perfectly. Ice adds moisture to the mixture, so it's added in small amounts to help achieve the desired juiciness and consistency in the final product. Keeping the mixture cold makes it easier to mix the ingredients evenly, ensuring a consistent flavor throughout the sausage production. You can see how the frozen meat and spices blend smoothly into a soft, even texture after being expertly ground, along with a bunch of ice being added in intervals and some other runny but important ingredients. Here come the eggs, a lot of them. These automatic machines are responsible for cracking the eggs and separating the yolks from the whites because only yolks are needed. This isn't a challenge thanks to these machines. The yolks are then whisked into the mixture to ensure a lump-free blend. This perfected mixture is then seamlessly integrated into the ground meat, crafting delicious sausages packed with savory flavors and made in countless delicious varieties. Sausages are a favorite food around the world. Now comes the next step, preparing the natural casing for sausages. It's soaked in cool water for at least 30 minutes to several hours, ensuring it's thoroughly washed to remove any residual salt and all prepared. It's moisturized with a touch of water to prevent drying and maintain its perfect form. The sausage mixture is carefully piped into the machine, ensuring it's shaped into specific sizes. See how these sausages emerge, perfectly shaped and glistening with a shiny finish, ready to delight your taste buds. Check out this natural casing holding your favorite sausage material. Just look at that consistency. After cutting, these sausages are coated with various flavorful sauces and undergo a pre-drying procedure for several hours. Your favorite sausages are now undergoing the crowning smoking process, which helps them gain that delicious flavor. This process also serves several purposes, which we'll expose in a bit. Finally, they move to the post-drying stage, where the changing color enhances their delicious appeal. In the next stage, they are prepared with natural sausage casings, evenly and securely tied to avoid air pockets. Stainless steel hooks or wooden rods are used to hang the sausages, ensuring they are evenly spaced to allow for adequate airflow between each one. This thoughtful arrangement ensures that during the drying and smoking process, each sausage receives consistent exposure to smoke and air, enhancing flavor and texture uniformly. Smoking sausages serves two main purposes. First, it adds a delicious smoky flavor that many people love. Secondly, smoking helps extend the shelf life of sausages. The smoke contains natural compounds that act as preservatives, helping to prevent spoilage and bacteria growth. This means sausages can last longer without the need for artificial additives. So yeah, smoking isn't just about taste. It's a smart way to preserve and enhance one of our favorite foods. After completing the drying process, the hanging sausages are carefully removed from the hooks or rods. Their color has transformed beautifully during this stage. Next, they are swiftly fed into a high-speed robotic system, where they are separated with precision using powerful air pressure. As they are getting ready, just imagine them perfectly tucked into a warm bun with mustard and onions. My goodness, I can barely focus now. Of course, how could we forget about the packaging? Each sausage is packed as carefully as it was crafted. They are placed in preset quantities in their desired boxes. Watch powerful hands tirelessly prepare the casing for sausages, but there's also a little friend that helps to fill up these casings automatically. Now they shape each sausage using precise measuring instruments and then carefully mold them by hand, preparing them for the drying process. For drying, each sausage is carefully hung one by one on iron rods, ensuring they attain the perfect shape and form. After a precise inspection to ensure top-notch quality, these savory treasures hang to dry and cure in a controlled environment, where their flavors deepen and mature. Maybe next time, before grabbing another bite of sausages, you will remember and appreciate the effort behind making those delicious sausages you eat. You might know those cheese cravings that refuse to quit until you take that first bite. Who's nodding along with me on this? If you can't resist grabbing a slice, even in the middle of the night, maybe we're in this together. Let's get straight to the stables, where hundreds of these beauties are kept safe and sound. And when I say safe and sound, I mean it. If you're wondering whether these cows are wearing yellow-colored earrings, no, in fact, they've got their number tags, so no cow is left unattended, and every beauty gets equal protocol regularly. You've probably heard that only healthy and happy cows provide nutrient-packed milk, so their diet and cleanliness are top priorities for farmers. Hey, stop. Where are y'all going? Oh, the milking facility. Let me show you around. This is the basic milking process that involves a bit of manual help, like installing the automatic milking devices and noting the required time to remove them immediately. Does that seem like a hassle to you? Worry not. I've saved 100% milking automation for you guys, so stick around until I get permission to show you the most secure and advanced milking facility. You might wonder how these cows cooperate so well. It's quite clear. Each cow is lured to its spot with its favorite food as positive reinforcement. The milking devices literally take a few seconds to detect the milking spots and connect to them automatically. Literally, no human hand is needed. This high-tech milking process can be completed in just 5 to 7 minutes, whereas hand milking can take much longer. Did you know that dairy cows are typically milked 2 to 3 times a day, ensuring a steady supply of fresh milk? It's true. Automated machinery offers immense benefits, yet many still prefer the old-school manual methods. These devices are directly connected to individual drums, where the milk is automatically collected without any outside contact, straight from cows to the drums. One major perk of large-scale milk production in factories is that human effort, once solely for milking, is now redirected to even more valuable tasks. Some advanced technology factories even use sophisticated milk meters to tally up each cow's milk production with high precision. After milking, an automated cleaning system sanitizes the equipment to maintain proper hygiene, keeping things squeaky clean. Large-scale production has now reached sky-high levels as we step into this magical world of mozzarella cheese. Every move follows precise guidelines. First, the fresh milk is poured and pasteurized to make it ready for cheese production, and of course, to kill any possible harmful bacteria present. This man carefully adds rennet, an enzyme, and some starter cultures like lactic acid bacteria to prepare the healthy curd for cheese processing. Rennet helps to coagulate the milk, while the bacteria acidify it, keeping the desired thick consistency of the curd they need. Once the curd reaches the right consistency, they use huge sieves, or special knives, to cut the curd into smaller pieces. This will help the curd to separate from the whey easily. The more it rotates, the more whey gets separated, giving the paramount cheese curd. It's getting easier to transfer into larger pots for further processing. Once collected into bigger, wide-open pots, these curds need to be cooled to room temperature, so it's easier to process the cheese curd further. it's good to test any step beforehand rather than improvising the whole thing at a bigger level. Time to shred the large cubes of solid curd into smaller chunks. If you've ever made mozzarella cheese at home, you'd probably know why this step is important, except now it's on a larger scale. As soon as the curd cubes are shredded into fine, smaller chunks, hot water is added through pipes to make the curd flexible for kneading. Yep, it's the most fascinating part of the entire cheese processing. This spinning or kneading is the most difficult part of the process because if you don't soften it just right, the mozzarella won't turn out to be the best you've always loved. But thanks to those experts, they can handle bulk production with so much care, never compromising on our stubborn taste buds. Once the cheese is kneaded perfectly, they just need to make small balls of cheese, and the machines will collect them automatically. Look how conveniently those mini cheese balls come out of their dedicated zones. Using a constantly running water stream makes the process way smoother. Let me walk you through some very curious stuff. Did you know that as cheese ages, it naturally changes its texture? Yes. With time, its moisture content decreases, resulting in a firmer, more crumbly texture that enhances its overall appeal. Some cheeses even develop a protective rind during aging, which not only preserves moisture, but also adds depth to its flavor profile. Unlike traditional manual methods, where each step requires significant human effort and time, automated systems streamline the process, allowing for faster production rates without compromising the integrity of the final product. This results in fresher, longer-lasting products that retain their flavor and texture until they reach consumers' tables. The right pH level ensures curds achieve their perfect texture, whether silky smooth or delightfully firm and stretchy. Who doesn't love vibrant colored ice popsicles in the summer? A special mixture for ice pops is poured into molds of specific shapes and left to set with sticks neatly in place. Of course, its appeal goes beyond just being a treat for kids. After a short time, all it takes is a cool temperature, and they fit perfectly into their molds. Recent research in the United States reveals that bulk ice pop production in factories boosts efficiency by up to 50%, cutting down on production costs while ensuring consistently high-quality treats for everyone to savor. Efficient packaging ensures that the ice pops are properly protected during transportation and storage, maintaining their quality and preventing any damage. Freshly harvested potatoes arrive at the factory, where the chosen potatoes are gently loaded onto a conveyor belt. This belt carries them smoothly into the heart of the washing area, where a steady stream of water showers over them. This stage is crucial for maintaining the potatoes' hygiene and ensuring they are free from any contaminants that could compromise their quality. After the initial rinse, the potatoes enter a brushing and scrubbing phase. Here, soft brushes mounted on rotating cylinders gently massage the potato skins. Once thoroughly washed, the clean potatoes proceed to a drying stage. This step is typically 2 in 1. They dry naturally while moving ahead toward further processing. Peeling, obviously. The potatoes enter the automatic peeling station, where abrasive rollers gently remove their skins. They are then moved to large choppers, which cut the potatoes into uniform chunks. This factory is truly multitasking, as it doesn't only prepare potatoes for silky smooth mashed potatoes, but also for various cuisines. For example, special cutters slice the potatoes into wedge shapes, so potato wedges are no longer a hassle. While some peeled potatoes are sent for further examination, experts pass the good quality potatoes to be cut into halves and packed immediately. Yes, because we can't wait to show you the satisfying process of making mashed potatoes in bulk. To prepare the creamiest and most flavorful mashed potatoes, the experts boil the potatoes right on the spot. While in many households, like mine, where spare time is an issue, already boiled potatoes, cooked a day or two before, are used to make mashed potatoes quickly. These experts know never to compromise on taste. When the potatoes are perfectly boiled, the unnecessary water is drained, and the steamy hot potatoes get their royal treatment in a smooth blender. As the main character, the potatoes are blended while butter is added bit by bit to ensure a thorough and creamy mix. Talk about creamy. To make mashed potatoes even creamier and dreamier, a specific amount of milk is poured in and mixed all over again. This gives the mashed potatoes a smooth texture and perfect consistency, making you crave more. And there you have it. The superheroes have undergone the ultimate transformation and are ready to be served as a delicious creamy side dish or main course. It totally depends on your taste. Never underestimate any small element, even if it's a nozzle, pouring equal quantities of mashed potatoes into every batch. It was truly a team effort. One of the famous international frozen pizza companies is on a mission to create the most delicious pizza ever. They start off with smooth, fluffy dough, which is balled up and spread out neatly in thousands of pizza pans for quick and partial baking. Meanwhile, the pizza sauce is being prepared and spread neatly over the baked dough by automatic machines. No manual help needed. You know cheese could go bad, so before it ruins the entire pizza party, they check it for top-notch quality beforehand. Once it's deemed good enough, the crushers shred entire blocks of cheese and sprinkle it over thousands of pizzas to give them a perfect texture. Some more cheese slices are neatly added on top. Finally, they pour on other sauces and ingredients, preparing the pizzas to be frozen right away. The pizzas are covered with a transparent food sheet and packed into boxes to keep them fresh and preserved. These machines don't demand appreciation, but they deserve it, don't they? So hit the like button for the sake of these and many other robotic machines working tirelessly to give you perfect outcomes every time. Just check out how this ordinary looking dough transforms into perfect buns with a single push of a button. Yes, this entire automation doesn't involve any manual help. Once balled up and rested in their dedicated pans, these fluffy dough balls rise for a couple of minutes. The vacuum then blows off extra crumbs, giving them a neat, finished look. When the buns are perfectly baked, they're all set to get dressed. If you like our video, please give it a thumbs up and support us in creating more content for you guys. As I always say, you're all we have. Look at those nozzles pouring delicious jam onto each half, giving you the best mouth-bursting flavors. Let's indulge in the golden sweetness of honey candies, where each bite is a taste of pure honey. Here, the process begins with a blend of pure honey and other required ingredients, transformed by super smart rollers into a thick, delightful mixture. This mixture is rolled out consistently and kneaded thoroughly. Just look at that consistency. It's so rich and smooth. It's amazing how these machines continuously knead the candy material without taking a break to ensure it perfectly meets your standards. Now, the little automated machines ensure that each candy gets the perfect and desired shape and cut. As the candies move through the production line, quality control sensors monitor each piece. These sensors check for consistency in size, shape, and texture. Once the candies have cooled and set, they are transferred to the wrapping machine. This machine wraps each batch of candies in protective packaging, keeping them fresh and preventing them from sticking together. Each pack holds around 9 candies, loved worldwide for their pure taste and eye-catching packaging. The wrapped candies are then packaged into boxes using large-scale packaging machinery. This step prepares the candies for distribution, ready for shipping. Stop messing with your sweet tooth. Nature. Not everything sweet is worth tasting. So grab only your favorite honey top biscuits that are rich in taste and super affordable. Do tell me when you find one. Jelly Belly candies are true gummy delights that are crispy on the outside, but burst with mouthfuls of liquid flavor the moment you munch them. First, the ingredients are mixed together in a large machine until the mixture is just right. Once the mix is ready, the machines pour it into molds to shape the candies. Now it's time for their rest, which doesn't take too long. Once the candies cool down, they're removed from the molds and spun in a special machine to ensure they're the perfect size shape, and texture. This process creates countless candies with tons of flavors to try. With so many different flavors, there's a Jelly Belly for every mood, and you're sure to find one you love. They ensure everyone can enjoy their favorite candy flavor and have a great time eating it. With so many different tastes, from fruity to sweet and everything in between, you'll never get bored. These treats turn snacking into a fun journey, letting you discover your new favorite flavor with every bite. When it comes to comparing super smart machines with human hands, robotic machines take the cake. They do everything super fast, perfectly, and with precision. Like right now, these machines are helping to create thousands of baked crusts to be filled with sweet and savory sauces for bakeries and restaurants. Loads of fresh meat are brought in and fed into a super fast chopping machine. This machine cuts it all into equal-sized pieces and neatly packs them into cans. Each tin is sealed tight and labeled with robotic precision in very little time. Creating perfect and smooth dough is a challenging task for human hands. However, for these magical machines, shaping dough into equal-sized pieces is no big deal. Once the dough is ready, the balls are prepared and undergo a smooth waffle-making process. This machine rolls and bakes the dough balls simultaneously, ensuring no additional time is wasted, with the results being absolutely flawless. In today's busy times, sandwiches are considered the perfect meal. Just pair one with a cup of coffee or tea for an easy energy boost. Advanced machinery prepares these sandwiches automatically, taking less time than you can imagine while packing a full energy punch. Different fruit flavors become uniquely delicious when transformed into sweet delights like candies. Robotic machines ensure these flavors are smooth and their textures consistent, making the taste incredibly delicious and enhanced. Robotic systems cut, shape, and create perfectly equal-sized candies in bulk in the blink of an eye. The candies are then moved to be wrapped in beautiful, eye-catching wrappers, ready to be enjoyed. Watch as these machines make the perfect donut-shaped sponge cakes, which are later topped and dipped into creamy, rich chocolate. Each donut is uniformly crafted and beautifully finished. To enhance the creamy flavor, a drizzle of chocolate syrup is added on top to make every bite a delightful experience. Once finished, they move on to the next process. Firstly, that beast machine steps into the fields and starts shaking, loosening the peanuts from the roots and turning them inside out. After the plants are dug up, they're left to dry in the sun for a few days. Now the excess moisture is removed from the peanuts, and they are ready to be picked up. Here come those bulky mechanical friends to do this job. Way much easier than it seems. It picks up the dried plants, separates the peanuts from other debris, and collects them in a hopper. From the last decade, China has been the largest producer of peanuts, and this strategic country usually makes a final count of around 20 million tons of peanuts every year. We have arrived at the facility where the entire peanut pile is fed into the cleaning setup. The unwanted stuff, like stones, twigs, and other foreign materials, is removed through pre-screening. This deshelling process is most satisfying when the machines delicately remove the outer shells of peanuts and reveal that beautiful, potential, and healthy nut we all were waiting for. Hang in there for a moment. They need to inspect manually for a quality check before they send the peanuts towards seed coating removing machines. Here, with gentle shaking, a lot of air pressure, and proper programming, that brownish skin is removed from the peanuts. The peanuts are treated with a medium boiling process to lock their texture and flavor and sanitize them by killing off any harmful bacteria or microorganisms by keeping the approximate boiling temperature near 121 stacking Celsius. However, it varies from company to company. As soon as the hopper is filled with the boiled peanuts, they are immediately packed and sealed in cans for distribution. These roasted peanuts are going to transform into something super buttery and delicious. Following a little roasting, the peanuts are cooled down to reach a temperature that is safe for handling and prevents them from becoming too hot or soggy during grinding. Those chosen peanuts take a trip towards this grinder and start revealing the smooth, buttery paste we all crave. It keeps grinding the peanuts until it reaches the desired smoothness, and the magic ingredients that will enhance the flavor keep being added little by little. This whirlwind of crushing and blending turns those nuts into pure deliciousness until it's homogenization. This step is chaos that gives way to harmony. Through higher pressure, the peanut butter gains its final and smooth texture. Witness this final stage where the bottles are getting filled and sealed to secure the fresh peanut butter inside. Automated machines, like filling and cap sealing machines, work tirelessly, ensuring each jar is brimming with creamy goodness. Each jar gets dressed up, ready to impress on the supermarket shelf. Whether spread on toast, topped over ice cream, or simply enjoyed with a spoonful, chocolate peanut butter never fails to delight the senses. Chocolate peanut butter serves the taste buds with its rich, creamy texture and harmonious blend of sweet and nutty flavors. Look at those different patterns those machines are creating to give us that satisfying sight. It's more like a powerhouse of protein and other essentials for muscle repair and growth. It's delicious and satisfies your hunger between meals. Those roasted peanuts are ready for a delicious chocolate coating. This chocolate coating process requires precision to ensure each peanut is evenly coated. After coating, the peanuts are left to cool and harden. Once cooled, they are carefully packaged into food-grade safe containers for distribution and sale. Have you ever tried these? Honestly, I never have. If we talk about those chilled, delightful ice creams, you all know it's pretty popular around the globe. Every day in the United States, people consume around 50 million ice cream pints. That's enough to fill more than 9 Olympic-sized swimming pools. Whether it's a hot summer day or a chilly winter evening, Americans' love for this sweet treat stays strong all year round. And why wouldn't it? Just look at how creamy, rich, and delightful they are. Have you ever tried these Taiwanese crackers? They are pretty familiar and loved by many, from adults to children. In addition to their delicious taste and texture, Taiwanese crackers are also celebrated for their simplicity. Made from basic ingredients, they create a magical burst of flavors inside your mouth. Their straightforward approach allows the natural flavors to shine through, resulting in an authentic and satisfying snacking experience. These snacks come in a range of textures, from crispy and airy to dense and crunchy. In the last few years, there have been several conspiracies about their oil spraying, but I don't think it is a problem. Because if you dig deeper, snacking as a whole would be considered unhealthy. But after much time, a little snacking won't hurt. Do you agree? No doubt at least their production is pretty satisfying to watch. Check out the magical power of these automated systems for juice-filling sectors, where every drop counts, reducing electricity consumption. You will barely see more than a few workers working around because of the efficient automation. Talking about these bulky productions is my love language. I always fall for them. Do you? If it's a yes, we are the same, bro. So cheers to that. I want you to comment down below and let us all know whether you prefer bottled or fresh juices and why that is. Think you had a hard time scooping out the sweet and juicy flesh from the pineapple shell? I ruined 4 large pineapples just to bring out a nice pineapple ring. Didn't waste the rest though. Surprisingly, burger meat patties are low in carbs. A beef patty typically has none unless extras are added. These delicious burger patties are full of energy and nutrients, perfect for fueling your day in the most appealing ways you have ever imagined. Dried apricots are far healthier, sweet-dried fruits that can be enjoyed on their own as a satisfying snack or added to various dishes like salads, oatmeal, trail mix, or baked goods for a natural sweetness and nutritional boost. However, it's important to consume dried apricots in moderation due to their concentrated sugar content. Strawberries are delicious, sweet, and one of the most consumed fruits worldwide. But the question is, how can we have them fresh throughout the year? It has become more convenient since companies launched canned foods. This way, we can enjoy fresh strawberries all year round, even when they are not in season. Popping open a can and getting a burst of summer in every bite, either to top on your morning yogurt or blend into a smoothie, these beautiful fruits give you a lovely vibe. Honestly, these chickens are far more taken care of here, secure and cleaned, than in other local farms. Even in those large poultry facilities, they keep an eye on every chicken using robotic scanners, so they know every chicken is healthy, happy, and playing in advanced barns. Plus, did you notice those eggs systematically laying on the front row? That's how their automation works. It's all being observed and monitored until the eggs safely reach these units, where they will be tested for quality, etc. Here, the eggs automatically arrange for several inspections, like leak detection and cleaning purposes. Now comes this major egg inspector, which will approve only good eggs before they go into the disinfection chamber to remove any microorganisms or pathogens. And lastly, they are ready to come your way. No matter how some people oppose the idea of bottled juices, soft drinks, or any other processed liquids having a limited time at breakfast, I fall for those bottled and tasty juices every time. We all know it's not a healthy activity. I mean, it hardly takes 10 to 15 minutes to extract fresh juice. Anyway, that's not just my problem. The majority of us choose convenience. I'm glad we made it out successfully, most importantly, together. And please take good care of yourselves. You are precious. If we need to make that yummiest jam, we probably should focus on the healthy growth of the fruits too. Now this matter is being set under a strict guide. But yeah, giving those pots the healthier and fluffy mud with the precise amount of materials. Now these robots start at the bottom by planting strawberry plants in containers or pouches. Water is essential, so they water each pot carefully to keep the strawberries happy and hydrated. When the strawberries grow big and red, it's time to pick them. For this purpose, this gigantic robot activates its clutches to delicately pick the ripened strawberries only. Since they're on different levels, it's easy to reach and pluck the delicious berries. This entire automation is so beautiful and satisfying. How these robots peculiarly pick up the strawberry from the stem and cut it without harming it. In botanical terms, berries have their seeds inside the flesh, but strawberry seeds are on the outside, so they didn't consider it in the berry list. Those fresh strawberries have arrived at their final destination, and here they will get even royal treatment. Just a little stop for a weight check. Once they make sure the demanded number of strawberries has arrived, they take them to the sorting units. And you better know what's going to be here with them. Of course, keeping you in mind, they're going to take that stack of strawberries for a manual check and make sure that only good quality strawberries are going further. Once they're sure of that, they let them pass on until they reach safe hands. Yep, these people are going to place each strawberry in that mold for the game-changing results. These robots automatically detect the green hull of a strawberry and beautifully just remove it without harming any other inch of the fruit. This is mind-blowing. Everything is under mechanical control. You can see how sharp eyes they have. Come on, they're doing this for you. Strawberries grow close to the ground, making them more susceptible to dirt, sand, and even tiny insects. The first wash, often a combination of water and little vibrations, removes these surface impurities. That's very important. But you know, fruits and veggies like these need another bath too. That's why they're given a second wash, often involving specialized sprays or misting with solutions like chlorine dioxide, which takes care of the tougher particles like pesticide residues and bacteria. This double trouble approach ensures the strawberries are as clean and safe as possible. They care about you. We care about you. See how honored we are to have you, just like these red, juicy strawberries. These fresh strawberries are now put into these containers. Yep, that's how you get the true and fresh flavor of frozen strawberries, because they are the same as, what to say, straight from farms to your plate. They are packed and firmly sealed to lock the pulpy fruit inside the food-grade containers. Just check out that large number of cans. Secondly, they use some of the frozen strawberries to make that glittery, yummy strawberry jam. All these frozen berries are put into the carriers to take them to the next stop, which is to load them into a container to add further ingredients. As the strawberries are loaded, now it's time to add further ingredients like sugar. They make sure the jam looks good, tastes good, and has the perfect texture. Once the handsome amount of sugar is poured, they need to control those figures and machines' capabilities by playing with some important buttons. The hot water tub is ready for these beautiful entities to enter and get bathed in the sweet syrup. What are they peeking at? Okay, the real drama has just begun. Once all the pulp comes to mix in that syrup, they put that material through sieves. This is important to give you that pulpless, smooth, jiggly jelly jam. Mixing, and more mixing. Everything is heated up in big pots or machines to make the strawberries blend and taste awesome. A special thing called pectin is added to make the jam just the right thickness. It's time to cook the material until it reaches its perfect texture, and that desired texture can be seen here. I think it's done. Yep, he's going to test the jam base to see if it's ready or needs to be cooked more. And yeah, it's good to go. Now the final process begins, to churn the mixture, to add a little more smoothness and to cool it side by side. A little now, it's like letting the flavors and texture settle and become best friends before they get packed into jars. And just wait, here we go. The whole warm jam base is ready. More close up here. It is, that creamy, smooth flow of my favorite jam. It's driving me crazy. Okay, time to pour that base and lock it in the jars. For that, these empty and starving bottles arrive. They are first neatly organized properly. The jam is carefully poured into jars all by itself. This process is usually automated in factories, with machines making sure each jar gets the right amount of fruity goodness. Here, we reach their sealing stage, where lots of lids are first picked in a proper style, beautifully conveyed to the roller coaster sort of belt, and finally to the sealing section where machines tightly seal the jars with lids. Okay, all those bottles are washed after being tightly sealed so that whatever sweetness remains on the outer side of the jars will be bathed away. We're now in the sticker section, where the robots will conveniently wrap stickers around these bottles so you will easily identify it's factory sealed. And of course, read that chart before eating anything. It's a good habit though. If you do, well, I don't. There's another technique too to add the labels one by one. All the bottles are labeled from whatever company they belong to and then piled up in the containers for the final bulk packaging. Bye-bye jam bottles. Don't forget my address and reach me soon. These mini jam bottles are filled up with the same freshness of fruit pulp and flavor to enrich your taste buds. Are those little nasty jam packets? You know, the ones at restaurants tucked next to the bread basket, bursting with fruity sunshine in one tiny bite. They're more than just sugar bombs. They might be tiny, but they're full of flavors to serve as starters for every meal. Also, these bite-sized marbles help stop food waste and make sure every spoonful is just right. These machines are the backbone of many industries, from food production to textile manufacturing to construction. With their robust blades and precise cutting mechanisms, they're built to tackle even the toughest materials. Imagine a scene where smoky aromas fill the air as meat sizzles on the grill, tantalizing taste buds with every flip and sear. Curious about the staggering output of flatbread producing machines in a single day? Prepare to be amazed. These efficient marvels can churn out an impressive number of flatbreads thanks to their high-speed capabilities and precision engineering. Depending on the size and capacity of the machine, production numbers can vary widely, ranging from thousands to even tens of thousands of flatbreads per day. Crafted with the finest ingredients and expert techniques, our pastries are a symphony of flavors and textures. Meet chocolate depositors, the sweet secret behind every delectable treat. Hazelnuts are packed with nutrients like protein, healthy fats, fiber, and various vitamins and minerals. Not only do they promote heart health and aid in weight management, but they also support brain function and contribute to healthy skin and hair. These little blue gems are packed with antioxidants, which help fight off harmful molecules in our bodies and keep us feeling great. Motivate us to create more satisfying videos like these and smash the like button. These factories aren't just about quantity, they're about crafting quality too, ensuring that each slice of salami delivers a burst of savory perfection. Removing the skin helps trim down on excess fat and calories. You see, much of the fat in chicken resides in the skin, so by peeling it off, you're opting for a leaner, healthier option. Additionally, without the skin acting as a barrier, marinades and seasonings can penetrate the meat more effectively, enhancing flavor throughout. Talking about almonds, you must eat them daily so you can remember us and keep watching our videos. Cheese holds a special place on plates globally, with millions indulging in its creamy goodness daily. Hey, if you're enjoying this video, make sure you hit that like button so we'll know how many people are interested in watching our upcoming videos. The ancient Egyptians were one of the first civilizations to enjoy sweets, using honey as a primary sweetener. That minced meat, also known as ground meat, is incredibly versatile and used in a wide array of dishes worldwide. From savory meatballs to juicy burgers, its adaptability knows no bounds. It all boils down to freshness and food safety. Ideally, you want to consume tray-sealed meat within a few days of purchase to ensure peak freshness and flavor. Let's crunch into the world of factory-made delicious potato chips. From sourcing the finest potatoes to adhering to strict quality control standards, these factories ensure that each chip meets the crispy, satisfying standard you expect. These machines are the backbone of large-scale food operations, capable of handling a wide variety of produce with speed and accuracy. These factory-prepared meals undergo stringent quality control measures to ensure they meet safety and nutritional standards. From automated sorting systems that ensure only the highest quality ingredients make it onto the production line to state-of-the-art packaging machines that swiftly seal products for freshness, these machines are essential for meeting consumer demand while maintaining high standards. Each pepper is carefully inspected for size, color, and quality, ensuring only the best make it to market. Each juicy bite is a refreshing explosion of tangy sweet goodness, leaving taste buds dancing with delight. These innovative contraptions are designed to streamline the process of pouring batter with precision and consistency. These machines are the masters of precision, effortlessly dispensing just the right amount of batter, dough, or filling with each press of a button. That's where the multi-head weighing machine shines. Its multiple weigh heads work simultaneously to ensure accuracy and efficiency. Imagine effortlessly removing the outer layer of fruits and vegetables with precision and finesse. That's the magic of these machines. From potatoes to oranges, they strip away the tedious task of manual peeling, saving you time and labor costs. But it's not just about convenience, it's about consistency. With peeling machines, you get uniform results every time, ensuring your products look as good as they taste. Wait, before watching this clip, were you thinking peeling fruit is the hardest thing to do? I mean, it's messy, but not anymore. It's not just about indulgence, there are benefits too. Chocolate breads pack a double punch of flavor and nutrition. Bursting with tropical flavor and juiciness, mangoes are nature's candy that never disappoints. From automated temperature control to efficient oil filtration systems, they're designed to optimize performance and minimize waste. In a modern Oreo manufacturing facility, key dry ingredients are delivered in bulk, often by rail cars or food-grade trucks, and are pneumatically conveyed into large storage silos made of stainless steel or epoxy-lined carbon steel. These silos are sealed from air and moisture and are connected to the factory's central control system. The main dry ingredients include unbleached, enriched wheat flour, processed cocoa powder, granulated sugar, and minor dry components like baking soda and salt. Each of these materials is handled in its own silo or hopper, and automated augers or vibratory feeders dispense precise quantities into batch weighing hoppers. These hoppers sit on load cells, sensitive scales that can measure down to a fraction of a gram. This is essential because the correct ratio of flour to cocoa to sugar directly affects not only the flavor, but also how the dough behaves under pressure during molding. If the cocoa content is even slightly too high, for instance, the dough may become too brittle and crack during forming. If it's too low, the wafers may bake up too soft, losing the crisp snap that defines an Oreo. Once the dry materials are batched, they are conveyed into a pre-mixing chamber. At this stage, powdered ingredients are briefly tumbled together to ensure initial homogeneity before liquids are added. Then it's time for the liquid components to enter the system. These include vegetable shortening, often a blend of palm and canola oil, along with a sugar syrup or glucose solution, invert sugar, lecithin, and vanillin or other flavoring agents. The fats and liquids are stored in temperature-controlled tanks and are metered into the mixer through heated pipes. The temperature of the fats is critical. Too cold, and they won't disperse evenly. Too hot, and they could melt too aggressively, breaking down the emulsion and affecting dough integrity. All of these components are combined in large jacketed horizontal mixers or double sigma arm batch mixers. These mixers are chosen for their ability to handle heavy, cohesive doughs while still ensuring thorough dispersion. Inside the mixer, paddles or blades knead the dough continuously, folding and stretching it to develop a uniform texture. The mixer operates under a specific time and speed profile, starting slow to incorporate the dry and wet components, then increasing speed to blend, then finishing with a gentle knead to avoid overworking the dough. The goal here is a dough that's soft but not sticky, cohesive but not tough. Sensors inside the mixing chamber monitor temperature and torque, two key indicators of dough readiness. If the dough becomes too warm from friction, it can become greasy and difficult to form clean edges in the molding machines. If it's undermixed, the ingredients won't be uniformly distributed, and inconsistencies in cookie size, color, and bake profile will result later on. Once the dough reaches its target specifications, it's discharged from the mixer through a hydraulically controlled trapdoor at the base of the mixing tank. The dough falls into a dough transport system, typically a set of conveyors or troughs lined with non-stick materials like Teflon or food-grade UHMW polyethylene. At this stage, the dough may still be slightly warm, around 30 degrees Celsius to 35 degrees Celsius, and has a dense, matte appearance with a strong cocoa aroma. Before moving to the forming machines, the dough must undergo a resting period in certain operations. This allows the flour to fully hydrate and any residual gases or trapped air to escape. In high-speed production environments, however, this rest period may be minimized or skipped altogether if the formulation is optimized for immediate processing. This completes the initial phase: ingredient intake, formulation, mixing, and dough discharge. Each step up to this point is carefully controlled by recipe management software that ensures no human error can affect batch consistency. Recipe locks, scanner-based operator identification, and redundant scale verification ensure each batch of Oreo wafer dough is made precisely to the specifications required to perform flawlessly in the next stage of the journey, shaping and embossing. Now that the chocolate wafer dough has been prepared with absolute precision, measured, mixed, and conditioned, it moves into one of the most visually iconic and mechanically fascinating phases in the Oreo production line: forming and molding. This step takes the dense, cocoa-rich dough and transforms it into thousands of uniformly sized, detailed cookie wafers, each embossed with the distinctive Oreo pattern. This is not simply cutting shapes out of dough, it's a highly engineered, high-speed process where consistency in shape, thickness, and surface detail must be maintained across millions of units every day. The freshly prepared dough is conveyed to a hopper positioned above a sheeter. This sheeter is a wide, stainless steel roller assembly that flattens the dough into a uniform sheet of specific thickness. The dough moves between a set of rollers, typically 2 or more steel cylinders calibrated to exact tolerances that compress it to the target height. For Oreo wafers, the final sheet is quite thin, often around 3 to 4 millimeters, with a consistent density and moisture distribution. Getting this thickness right is critical. If the sheet is too thick, the cookie may not bake evenly or could become too brittle. Too thin, and the cookies may crack, burn, or crumble during sandwiching. Sensors measure the thickness of the sheet continuously using laser or ultrasonic gauges. If deviations are detected, servo-driven actuators automatically adjust roller spacing to maintain precision. The sheeter also includes edge trimmers, small, motorized blades that cut off uneven or frayed edges of the dough sheet to keep the line uniform. The trimmed edges are collected by a scrap recovery system and reintroduced into the mixing system, minimizing waste without compromising freshness or quality. Once the dough sheet is perfected, it enters the rotary molder. This machine is central to the Oreo brand's identity, as it forms the shape, size, and embossed design of each cookie wafer. The rotary molder consists of 2 primary components: a rotating die roller and a pressure roller. The die roller is a cylindrical drum engraved with multiple cavities, each one precisely carved with the Oreo design. These cavities aren't just cosmetic. Their depth and contour dictate the final relief of the cookie surface. As the dough sheet passes between the die roller and pressure roller, each cavity punches into the dough, compressing it into shape and imprinting the Oreo design. The pressure roller, covered in food-safe rubber or polymer, pushes the dough up into the die cavities, ensuring a clean, complete mold. As the die drum continues rotating, the shaped wafers are extracted by a combination of mechanical pushes and vacuum assist systems, which gently remove the cookies from the cavities without smudging the design. These freshly molded cookie wafers are then transferred onto a wide mesh conveyor belt in a continuous, uninterrupted line. Each wafer is spaced evenly to allow for proper airflow in the next phase, baking. Meanwhile, the excess dough surrounding the cutouts, known as webbing, is carefully separated and sent back through the scrap system. This recovery loop is highly efficient, capturing nearly 100% of the unused dough and returning it to the mixer via chilled transport belts. To ensure product consistency, reworked dough is blended at a fixed percentage into fresh dough, preventing any changes in texture, flavor, or moisture that might result from over-processing. As the line of uniform, molded Oreo wafers advances, they approach the baking tunnel, one of the most thermodynamically sophisticated parts of the facility. The tunnel oven is a massive structure, often exceeding 30 meters in length, segmented into multiple temperature-controlled zones. Each zone is precisely tuned to manage the gradual dehydration and expansion of the cookie, ensuring even baking from edge to center. The ovens use convection, conduction, and in some cases, radiant heat, depending on the equipment manufacturer and regional factory specifications. The cookie wafers bake as they travel slowly through the tunnel, typically for a duration of 4 to 6 minutes. Conveyor speed, airflow rate, and internal oven temperatures are continuously adjusted via programmable logic controllers that interface with sensors monitoring internal humidity, surface temperature, and even color of the baking cookies using infrared imaging systems. The target bake is one where the cookie becomes crisp and fully set while retaining a slight moisture gradient at its core, enough to ensure it sandwiches cleanly without shattering, and holds up in milk without becoming soggy too quickly. Another crucial parameter monitored at this stage is cookie spread and diameter. Because the molded wafers expand slightly as they bake, their final size must fall within a fraction of a millimeter to ensure they'll match perfectly with their paired half during sandwiching. Edge blowout, where cookies develop uneven bulges or bubbles, is prevented by careful control of initial dough temperature, mold compression depth, and oven humidity during the first baking phase. As the cookies exit the oven, they are immediately passed through a staged cooling system. This phase is designed to gently bring the cookies from their internal post-bake temperature of roughly 160 degrees Celsius down to ambient room temperature. Cooling too quickly can cause the wafers to crack, warp, or experience checking, tiny surface fractures that affect aesthetics and structural integrity. To avoid this, the conveyor slowly moves the wafers through a series of cooling zones with progressively decreasing airflow temperatures. High-volume fans push filtered, dehumidified air over the wafers in a cross-flow pattern that cools them evenly on all sides. By the time the wafers reach the end of the cooling tunnel, they are firm, crisp, and at a stable moisture level, typically around 1.5% to 2%. This ensures maximum shelf life, a satisfying crunch, and ideal compatibility with the creme filling in the next phase of production. They are now ready for alignment and pairing. Wafers are automatically aligned into dual streams using diverters and channeling guides. Conveyor belts, equipped with vision systems, scan for defects such as missing embossing, chips, discoloration, or breakage. These systems use high-speed cameras and AI-assisted pattern recognition to detect any imperfections in milliseconds. Rejected cookies are diverted to a waste collection hopper, and approved wafers continue forward to the sandwiching stage. With the Oreo chocolate wafer cookies fully formed, baked, and cooled, the production line now transitions into one of the most iconic and mechanically synchronized parts of the process: sandwiching. This stage involves the precise alignment of two delicate wafer halves around a carefully deposited swirl of creme filling, forming the complete Oreo cookie as we know it. What may seem like a simple task, placing filling between two cookies, is in fact a highly controlled and technically advanced process that prioritizes speed, accuracy, hygiene, and product consistency. The cooled wafers arrive at the sandwiching station via dual-lane conveyors that separate and feed cookies into two different orientations: bottom wafers and top wafers. The bottom wafers are destined to receive the cream filling, while the top wafers are held back momentarily, synchronized to arrive just as the filling has been deposited. Vision-guided pick-and-place arms or mechanical guides ensure that each cookie is properly positioned and oriented with the embossed design facing upward, especially important for branded recognition in the final presentation. The placement needs to be exact. Even a slight misalignment could result in uneven sandwiching or a crooked creme center, which would be rejected downstream. At the heart of the sandwiching line is the creme depositor. This component is engineered to dispense a precise amount of creme onto the center of each bottom wafer. The creme filling itself has been prepared earlier in the process and is stored in stainless steel holding tanks near the sandwiching line. The base creme is a blend of vegetable shortening, powdered sugar, and natural or artificial flavorings, aerated to achieve a smooth and creamy texture. It is kept at a controlled temperature, typically between 25 degrees Celsius and 30 degrees Celsius, to maintain flow consistency without being too runny or too firm. The creme is pumped into the depositor through a jacketed delivery line, which maintains temperature and prevents any hardening or separation. Inside the depositor, a rotary valve system or piston-driven nozzles release measured quantities of filling in circular swirls directly onto each passing wafer. The target deposition amount is extremely precise, usually around 3 grams per cookie for the original Oreo. For double stuff, the system is calibrated to deliver twice that volume, and the depositor nozzle height is adjusted accordingly to accommodate the larger swirl. The deposition speed is synchronized with the conveyor, meaning each swirl is deposited while the bottom wafer is in motion. To maintain consistent swirl shapes, the nozzle spins at a high RPM as it dispenses the cream. Sensors and imaging software track swirl size, height, and position. If the deposit strays from the central zone or falls outside weight tolerances, that cookie is automatically flagged and diverted. These sensors run continuously, sampling thousands of cookies per minute with extremely tight thresholds for variance. Once the creme is in place, the top wafer is gently placed onto the swirl. This is done by an overhead transfer arm or drop chute designed to lower each top cookie into place with just enough pressure to make contact without squashing the filling. The timing here is critical. Placing the top wafer too early could create smearing or incomplete adhesion, while placing it too late could allow the creme to set and result in a loosely held sandwich. Once the two halves make contact, a calibrated compression roller or paddle gently presses them together to create a uniform sandwich with a visible, even creme edge. The newly assembled Oreo cookies are then conveyed forward to undergo another round of quality inspection. At this stage, high-speed vision systems again scan for defects. These include cracked or broken wafers, misaligned sandwiches, off-center cream, or excess filling that has oozed out past the edges. Cookies that fail to meet standards are ejected via pneumatic pushers or retractable gates, landing in separate bins for non-conforming product. These rejected cookies are either discarded or recycled depending on factory policies and whether they passed earlier food safety checks. The good cookies move on to the next major phase, cooling and setting. Even though the creme filling is solid at room temperature, the act of depositing and sandwiching generates residual warmth, and the filling remains somewhat malleable for several minutes. To stabilize the sandwich structure and ensure long-term integrity during packaging and shipping, the cookies are passed through a controlled cooling tunnel. This tunnel gradually brings the product's temperature down to a stable point, typically just below ambient, which firms up the cream and locks in the sandwich's structural cohesion. As cookies exit the cooling tunnel, they are directed toward the packaging line. Here, the cookies are grouped and arranged into stacks or rows depending on the intended package format, whether it's a classic tray-style retail pack, a resealable pouch, a single-serving sleeve, or a multi-pack unit. For traditional packs, the cookies are guided into channels that group them into stacks, typically of 3 or more, which are then lowered into thermoformed plastic trays by robotic pick-and-place units. These trays help protect the cookies from damage and keep them organized for end-user convenience. Parallel to this, packaging film, pre-printed with branding, nutritional labels, and product information, is unwound from large rolls and fed into a form-fill seal machine. As the cookie-filled trays pass through the machine, the film is wrapped around the product, heat-sealed on all sides, and trimmed to size. Oxygen scavengers or desiccants may be inserted for freshness in some markets, depending on climate and shelf life requirements. For resealable packs, a Ziploc or peel-back adhesive strip is applied as part of the film sealing process, ensuring that consumers can open and close the package without reducing freshness. Each package unit is printed with a lot number, manufacturing date, facility code, and expiration date using high-speed thermal inkjet or laser printers. These codes enable full traceability and are cross-referenced with the production batch data stored in the factory's ERP system. From mixing and molding to creme filling and sealing, every step of the process can be traced back to specific machines, operators, shift schedules, and ingredient batches, an essential feature for food safety compliance and recall readiness. Once sealed, packages are conveyed to automated case packers. Here, robotic arms load the wrapped units into corrugated cardboard cartons, which are then glued or taped shut. These cartons are palletized according to preset patterns that optimize load stability and cube efficiency for shipping. Pallets are wrapped with stretch film, labeled with shipping barcodes and inventory data, and routed to the warehouse staging area. At this point, the Oreo cookies have completed their physical transformation from separate cocoa wafers and creme filling into a polished, fully packaged, ready-to-ship product. But before they leave the factory, they undergo a final quality audit. Samples from each batch are pulled from the finished goods line and tested by in-house sensory panels and laboratory staff. Taste, texture, aroma, appearance, and moisture content are evaluated to ensure that the product not only looks perfect, but delivers the consistent flavor and mouthfeel that Oreo is known for. Moisture levels are especially critical. Too high, and the cookie can lose its crispness during storage. Too low, and it can become brittle or stale. Texture analyzers apply mechanical pressure to the cookies to evaluate crunch resistance and breaking force, while gas chromatography is used to verify flavor compound profiles. Packaging integrity tests include drop tests, seal strength verification, and temperature cycling simulations that mimic transport and storage conditions across various markets. Once these final inspections are passed, the cookies are released for distribution. Pallets are loaded into climate-controlled trucks or containers, routed through regional distribution centers, and ultimately arrive at retail outlets, vending networks, or direct-to-consumer channels. With the Oreo cookie now fully assembled, inspected, packaged, and palletized, the final phase of the in-factory process is dedicated to the logistics, storage, inventory control, and outbound quality assurance systems that prepare the product for global distribution. While it may seem like the technical complexity is behind us, this stage involves its own set of sophisticated workflows designed to ensure that every package remains pristine, traceable, and shelf-stable for months after production, regardless of whether it ends up in a small, rural convenience store or a high-volume urban supermarket. The finished pallets of Oreos are moved from the end-of-line palletizing systems into a dedicated finished goods warehouse. This space is part of the factory complex, but isolated from production to prevent cross-contamination and maintain temperature and humidity stability. Oreo cookies, especially those with creme fillings, are highly sensitive to environmental changes. Excessive heat can soften the filling or compromise the packaging seal, while high humidity can cause moisture migration into the wafer, leading to loss of crispness. To combat these risks, the warehouse is maintained at a tightly regulated temperature, typically between 18 degrees Celsius and 22 degrees Celsius, with relative humidity kept under 50%. The facility is segmented into climate zones for different packaging formats, with certain areas reserved for international shipments that may require added humidity resistance or longer storage durations. Air handlers, industrial-grade dehumidifiers, and air filtration systems constantly regulate and cycle the air to maintain these parameters. Even the lighting systems are designed to minimize UV exposure, which could, over time, degrade packaging ink or food contact films. Once inside the warehouse, each pallet is scanned and logged into a warehouse management system. This system is fully integrated with the factory's enterprise resource planning software and allows operators to track not only where each pallet is stored, but exactly what production line, time, and ingredient lot was used to produce its contents. Each pallet label includes a unique serial number, barcode, and QR code that links to this full production history. This traceability is essential not just for internal logistics, but also for compliance with food safety regulations around the world, which require manufacturers to be able to track every product from raw ingredient to final point of sale. The WMS automatically arranges pallets by product type, batch date, and destination. Those scheduled for export may be routed to a separate staging zone where they will be checked for compliance with international packaging laws. Different markets may require translated labels, adjusted nutritional formats, or modified lot codes. Some export destinations also require additional tests, such as microbial swabs or accelerated shelf life sampling, to meet foreign government regulations. These are performed in an adjacent quality control annex, and only upon clearance are these pallets released to outbound logistics. Before any Oreo shipment leaves the facility, it undergoes a final visual inspection for physical damage to packaging, tamper seals, and box integrity. Any visible damage may indicate mishandling during internal transit or weak spots in pallet stability. Operators are trained to look for warped trays, compromised seals, or even small tears in the flow wrap film that could affect product freshness. Should any defect be discovered, that pallet is held for secondary inspection, and depending on severity, it may be repackaged or scrapped entirely. At this point, logistics coordinators use automated routing systems to schedule outbound shipments. These systems factor in geographic location, delivery deadlines, climate conditions, and truck availability. For example, shipments bound for warmer climates during the summer may be prioritized for insulated or refrigerated trucks to prevent the creme from softening. Long-haul shipments may be routed through distribution centers that offer cross-docking or climate-controlled storage to preserve product quality along the supply chain. The loading dock itself is operated with precision. Trucks arriving at the facility must be cleaned, inspected, and approved before any Oreo products are loaded. This includes visual inspection for pests, residue from prior shipments, and confirmation that the trailer temperature is within specification. Only after a truck passes these inspections does the facility open the dock door and begin the loading sequence. Robotic forklifts or human operators load the pallets according to pre-planned diagrams that ensure weight is evenly distributed and product is easily accessible at the destination. Each shipment is logged with time, driver ID, carrier information, route ID, and estimated delivery window. Once loaded, trucks are sealed with tamper-evident locks and dispatched with digital shipping documents, including delivery confirmations and scanned QR codes for receiving teams. The WMS updates the ERP system in real time, closing the inventory loop and marking the batch as shipped. This inventory and logistics traceability is crucial for meeting compliance with global food safety standards like the Global Food Safety Initiative, hazard analysis, and critical control points, and ISO 22000. Even after the Oreo product leaves the plant, the factory remains connected to its life cycle through digital feedback systems. Retailers and distributors have access to portal-based interfaces where they can report damages, delayed deliveries, or unexpected inventory issues. Returned products are scanned upon arrival at reverse logistics zones where factory staff investigate issues, analyze production records, and determine root causes. In cases where errors are found, such as premature staleness, flavor imbalance, or packaging failure, continuous improvement protocols are triggered to address the upstream causes. While these systems function to protect the product, they also feed into a broader factory goal: performance analytics and continuous optimization. The data from every shipment, temperature logs, shipping duration, breakage rates, seal integrity, and even consumer complaints is compiled into dashboards reviewed weekly by production leads QA managers, and logistics coordinators. These dashboards enable the factory team to track KPIs like OTIF, defect per million rates, inventory turnover, spoilage reduction, and carbon footprint per pallet. Some Oreo plants are moving even further towards sustainability at this stage of production. Cardboard shipping boxes are made with recycled content and are themselves fully recyclable. Pallet wrap films are being downgauged or replaced with biodegradable alternatives. Facilities are experimenting with hybrid electric fleet partnerships or rail transport instead of trucks to reduce emissions. In select markets, even the plastic trays inside Oreo packs have been redesigned for recyclability, and clear labels now inform consumers on proper disposal. Creating millions of Almond Joy bars every day takes a perfectly synchronized process of speed and sweet engineering. Inside high-tech factories, coconut is shredded and coated in smooth chocolate, all in a matter of seconds. In this documentary, we take you behind the scenes to uncover the fascinating journey of how this iconic candy bar is mass-produced. Manufacturing Almond Joy candy bars on an industrial scale begins long before any chocolate is melted or coconut is mixed. It starts with the careful sourcing and preparation of one of the candy's most iconic and defining components, the coconut. This isn't just any shredded coconut. This is a specific, moisture-balanced, finely textured variety that gives Almond Joy its distinct chewy center. Producing coconut to these specifications requires a highly controlled and deliberate process. And in modern facilities, this step alone involves extensive coordination between agricultural suppliers, food scientists, and processing engineers. The coconuts used in Almond Joy bars are primarily sourced from tropical regions like the Philippines, Indonesia, and India, where coconut palms grow in warm, humid climates and are harvested multiple times per year. The coconuts are selected based on strict criteria such as maturity, size, and oil content, all of which contribute to the flavor and structure of the final product. After harvesting, the outer husks are mechanically removed using rotary dehusking machines, exposing the inner brown shells. These shells are then cracked open using high-torque hydraulic presses or mechanical splitters, allowing access to the white coconut meat inside, also known as copra. Once separated from the shell, the coconut meat is washed in large stainless steel tanks using filtered water, sometimes with a light chlorine solution to remove any contaminants, shell fragments, or residual dirt. The clean coconut meat is then graded using high-speed rotary shredders, which reduce it into uniform strands. These industrial shredders operate at several thousand RPMs and are fitted with specialized blades designed to achieve a consistent flake size. The exact dimensions of the shredded coconut are critical. Too coarse, and the texture becomes stringy. Too fine, and it loses its chewiness. The shredded product is then passed through vibratory sieves to remove any oversized or undersized particles, ensuring each flake meets factory specifications. Once the coconut is shredded and sized, it undergoes a drying phase, designed not to fully desiccate the coconut, but to bring its moisture content into a very specific range, typically between 12 and 14%. This drying process is carried out in large belt dryers or fluidized bed dryers that blow heated air over the coconut shreds while keeping them suspended and moving, ensuring even drying throughout. Sensors embedded in the dryer constantly monitor moisture levels in real time, allowing for micro adjustments to airflow and temperature. This precision ensures that the final coconut retains its soft, moist chewiness without being wet or prone to microbial spoilage. Once dried, the coconut is cooled with ambient air and sent through a metal detection system before being packed into sterile bulk totes or drums, ready to be delivered to the candy production line. Now it's time to go into the coconut syrup blending process, where the prepped coconut is transformed into the moist, sweet filling that forms the base of every Almond Joy bar. At this stage, the dried coconut shreds are transferred from storage bins into large stainless steel ribbon blenders or planetary mixers. These mixers are food grade and designed to gently fold the ingredients together without compressing or overworking them, which would damage the texture. While the coconut is being added to the mixer, a separate part of the factory is simultaneously preparing a sugar syrup that will serve as the binder and sweetener. This sugar syrup is cooked in large steam-jacketed kettles, each fitted with agitators and temperature sensors. The syrup typically contains a blend of sucrose, corn syrup, and a small percentage of invert sugar, which helps prevent crystallization and keeps the final mixture smooth and cohesive. The ingredients are combined with water and brought to a boil, then held at a precise temperature of around 230 to 240 degrees Fahrenheit. Once the syrup reaches the desired consistency and viscosity, it is pumped through insulated transfer lines into the mixers containing the shredded coconut. The hot syrup is slowly added into the mixing chamber while the paddles rotate at a controlled speed, ensuring that every strand of coconut becomes evenly coated. This mixing step is closely monitored for torque resistance, an indirect measure of viscosity and saturation. If the mixture becomes too stiff, it indicates that not enough syrup has been added, while an overly slack consistency could suggest too much moisture. Adjustments are made in real time, either by slowing down the mixing blades or by adding additional syrup in carefully measured quantities. The end result is a glossy, dense, and aromatic coconut mixture with a smooth mouthfeel and a controlled stickiness that allows it to hold together when molded. This freshly prepared filling is discharged from the mixer into temperature-controlled holding hoppers. From there, it is fed through sanitary auger systems into the forming line, where the next phase of production begins, shaping each bar's core. But up next is the forming process, where this cohesive coconut mixture is portioned and molded into the rectangular log shape that defines the inner core of every Almond Joy. This step is handled by a specialized extrusion and forming system. The mixture is continuously extruded through a die system that determines the width and height of the log. These forming dies are custom designed for Almond Joy and produce a consistent cross-section with slightly rounded tops, ensuring a uniform bite and a reliable surface for almond placement. The extrusion head releases a continuous ribbon of coconut mixture onto a moving conveyor belt, and a high-speed rotary guillotine, timed with the conveyor's speed, cuts this ribbon into individual bar-length pieces. The distance between each cut is controlled down to the millimeter, and a sensor-based feedback system ensures that every bar is exactly the same size. After cutting, a short air blast is applied to each log to clear away any stray coconut flakes and ensure clean edges. As the bars are cut, they enter a cooling conveyor that travels through a tunnel kept at approximately 45 degrees Fahrenheit. The cooling process is essential at this point. Not only does it help the bars hold their shape, but it also stabilizes the sugar syrup binder so that the mixture doesn't slump or deform in the next step. A key consideration during this cooling stage is air humidity. If the environment is too dry, the coconut can begin to crust or dry out. Too humid, and condensation may form, which can affect downstream adhesion with the chocolate coating. For this reason, industrial humidity control units maintain relative humidity levels around 45 to 55% inside the cooling tunnel. Once cooled and firmed, the coconut logs are transferred by conveyor to the almond placement system. Each log must receive exactly 2 whole almonds, neither more nor less, positioned evenly across the top surface. The almonds used in this process are themselves the result of a careful preparation sequence. Raw almonds are sourced from large-scale growers, often in California, and are received at the factory in bulk containers. These almonds are sorted, cleaned, and then dry roasted in large convection ovens. Roasting enhances flavor, reduces moisture to less than 5%, and gives the almonds the crunch consumers expect. After roasting, the almonds are cooled and transported to a hopper above the placement system. Here, they are singulated, separated into single file, and guided into individual almond placement arms. These arms are controlled by a vision-guided robotic system that tracks the position of every coconut log in real time. Using photoelectric sensors and high-resolution cameras, the system places each almond with millimeter-level accuracy on top of the log. The almonds are pressed into the surface just enough to adhere without sinking. And an inline inspection system checks that every bar has precisely 2 almonds aligned correctly. Any bar that deviates from this standard is removed from the line for manual inspection or rework. Now it's time to go into the chocolate enrobing stage, which marks the beginning of the transformation from a basic assembly of ingredients into the finished, glossy, consumer-ready candy bar. This process involves fully coating the almond-topped coconut cores with a layer of milk chocolate. But this is no ordinary chocolate. It has been specifically formulated and tempered to provide the right snap, shine, and melt-in-the-mouth texture that defines the Almond Joy eating experience. The chocolate is stored in holding tanks maintained at 110 to 115 degrees Fahrenheit and stirred continuously to ensure it remains fluid and free from separation. Before use, the chocolate is tempered through a process that heats, cools, and reheats it to align the cocoa butter crystals in a stable form. Proper tempering is essential as it prevents fat bloom and gives the coating its glossy finish and clean break. The tempered chocolate is pumped into an enrobing machine, which dispenses it in a continuous curtain across the width of the conveyor belt. As the coconut and almond cores pass underneath, they are fully submerged in the falling sheet of chocolate, while a bottoming unit applies a layer of chocolate to their underside. Immediately afterward, a series of air blowers remove excess chocolate, ensuring a uniform thickness and revealing the shape of the almonds beneath. What emerges is a fully coated bar that looks and feels like the final product, but still needs time to set. That step begins as the bars enter a temperature-controlled cooling tunnel, and that's where the next phase begins. Inside the cooling tunnel, a meticulously engineered, climate-controlled chamber extending over 30 feet in length, the freshly enrobed Almond Joy bars begin their chocolate setting phase. This tunnel is one of the most crucial parts of the process, ensuring that the tempered chocolate coating transitions from a glossy liquid into a solid shell with the perfect texture and finish. The chocolate must cool at a precise rate, not too fast, which could result in cracking or sugar bloom, and not too slowly, which could cause the cocoa butter crystals to misalign, leading to dullness or fat bloom on the surface. The tunnel operates at an ambient temperature between 45 and 55 degrees Fahrenheit, and relative humidity is tightly controlled around 50%. High-efficiency fans circulate cold air evenly across all bars on the conveyor, and temperature sensors track minute variations along the length of the tunnel. The speed of the conveyor is carefully synchronized with the chocolate's crystallization curve so that the bars spend just the right amount of time cooling, usually between 7 and 12 minutes, depending on environmental conditions, line speed, and chocolate thickness. During this stage, the chocolate coating fully hardens around the coconut and almond core, creating a glossy, smooth outer layer that locks in moisture and flavor. The almonds, having been gently pressed into the top of the coconut before enrobing, remain clearly visible through the chocolate shell, creating the bar's iconic bumpy silhouette. As the bars exit the tunnel, they are now fully formed, with all primary ingredients integrated and stabilized. But the next phase, inspection and quality control, ensures that only perfect bars make it into the hands of consumers. The next step is the multi-layered inspection and quality assurance phase, a critical junction in the Almond Joy manufacturing process. Here, Each fully cooled, enrobed bar passes under a series of digital scanning systems equipped with high-resolution cameras and sensors that detect inconsistencies in shape, size, and appearance. These systems analyze every bar in real time using image recognition algorithms trained to identify surface defects, incomplete chocolate coverage, missing almonds, or any signs of misalignment. Each camera system captures dozens of images per second, creating a detailed digital fingerprint of each bar. If a defect is detected, such as an air bubble on the surface, a chocolate smear, or a misaligned almond, the bar is automatically rejected using a quick puff of compressed air that directs it off the main conveyor into a designated collection tray. Rejected bars are recorded and analyzed in quality control logs to monitor trends and flag any upstream issues in real time, like syrup inconsistencies or almond placement variances. Following the visual inspection, the bars pass through an inline check weighing station. This precision balance system measures the mass of each individual bar down to the 1/10 of a gram. Bars that are even slightly under or overweight are flagged and rejected from the line. This strict weight control not only ensures product consistency and consumer satisfaction, but also regulatory compliance, as all packaged goods must meet labeled net weight declarations. These check weighers are recalibrated frequently during production to maintain absolute accuracy, and the results are logged digitally to provide traceable batch records. Next, a random sampling process is initiated where trained human inspectors pull sample bars from the line every few minutes. These samples are taken to a nearby quality assurance room for deeper evaluation. Inspectors slice open the bars and examine the cross-section for proper ingredient distribution, moisture retention in the coconut layer, almond placement, and shell integrity. Taste testing is performed by a trained sensory panel in a separate tasting room to ensure the flavor profile remains consistent. Parameters like sweetness, chewiness, and chocolate snap are all evaluated and recorded in a detailed quality report. Once bars have successfully passed through the inspection phase, they are ready for the next stage, packaging. But up next is the flow wrapping process, where each Almond Joy bar is individually wrapped using high-speed machinery designed to maintain hygiene, preserve freshness, and uphold branding consistency. The packaging film, pre-printed with the Almond Joy logo and product information, is loaded in giant rolls at the start of the packaging line. These rolls are threaded through a series of rollers and tensioners that keep the film aligned and taut as it's fed into the wrapping unit. The bars are spaced and synchronized onto a conveyor lane and fed into the flow wrapping machine, which envelopes each one in film and seals it at the sides and ends using heated crimping jaws. These jaws press the film together and apply controlled heat and pressure to create airtight seals that are strong yet easy to open. The sealing temperatures are carefully monitored to avoid overheating the chocolate within, as excess heat could cause the surface to dull or soften. Each wrapped bar is then passed under a thermal inkjet or laser coder, which prints the best before date, batch code, and production time directly onto the wrapper. This traceability information is vital in case of recalls, inventory tracking, or shelf life analysis. Vision sensors verify the presence and clarity of the code, and any missing or illegible codes trigger a rejection mechanism. The speed of this entire process is remarkable. Modern flow wrappers can handle upwards of 500 bars per minute, all synchronized perfectly to match the upstream enrobing output. Once wrapped and coded, the Almond Joy bars are grouped into retail-ready formats. Depending on the destination, this could mean twin packs, king-size versions, or standard singles in cartons. Cartoning machines fold and glue cardboard sleeves or cartons, then insert the correct number of bars automatically. These cartons are scanned for correct orientation, closed, and labeled with shipping and SKU data. A final check weigher ensures that the total weight of each carton falls within specification. and the completed units are then moved down the line to case packing. The case packing phase involves automated robotic arms or pick-and-place systems that lift finished cartons and place them into larger, corrugated shipping cases. The arrangement within each case is optimized for pallet stability and protection during transit. Each case is labeled with product identifiers, batch codes, and destination information, then sealed and conveyed to a palletizing station. Palletizing robots stack the cases onto wooden or plastic pallets in precise configurations to maximize space and maintain structural integrity during transport. Once a full pallet is assembled, it's wrapped in high tensile stretch film using automated rotary arm or turntable wrappers. This wrapping secures the load against shifting during transportation and also provides a barrier against dust and moisture. Each pallet is then tagged with a barcoded shipping label that includes tracking information, weight, and customer-specific handling instructions. The completed pallets are moved to a climate-controlled storage area within the warehouse to await shipment. Now, it's time to go into the logistics and distribution stage, where the focus shifts from production to coordinated movement and inventory management. Almond Joy bars, like all Hershey's products, are managed within an enterprise resource planning system that tracks production batches, inventory turnover, and customer orders in real time. Based on demand forecasts, pallets are selected for outbound shipment, assigned to specific trucks or containers, and scanned out of the warehouse with full digital traceability. Transport is typically handled using refrigerated trucks during warmer months, as the milk chocolate in Almond Joy bars is sensitive to heat. Temperatures are maintained between 55 and 65 degrees Fahrenheit during transit, and GPS-linked thermal loggers monitor each vehicle's internal climate from origin to delivery. If a truck deviates from its safe range, alerts are sent to both logistics managers and warehouse supervisors to prevent spoilage. Once the bars reach regional distribution centers or retail warehouses, the product is scanned into inventory and routed to store shelves. Retail partners rely on synchronized inventory systems that replenish stock as it sells, often based on point-of-sale data. The entire journey, from Coconut Grove to grocery store, can be completed in just a matter of weeks, but every phase must function flawlessly to deliver a bar that meets Hershey's standards for quality, freshness, and consistency. And even once the product hits shelves, the factory's job isn't done. Ongoing consumer feedback, seasonal demand changes, and promotional cycles influence continuous adjustments in batch sizes, production schedules, and packaging variations. Special holiday versions, multi-packs, and limited time offers are all planned months in advance and require tailored processes, new molds, and reprogrammed machinery, an impressive level of flexibility embedded within an otherwise standardized production system. Quality assurance continues to play an active, ongoing role in the manufacturing of Almond Joy, even after the bars have been wrapped, packed, and prepared for distribution. In fact, behind the scenes of the main production line, a parallel infrastructure operates continuously to monitor, record, and validate every element of the process in real time and long after the initial production phase. This includes not only in-process checks, but detailed post-production sampling and retention, which are central to traceability, regulatory compliance, and product consistency. One critical ongoing practice is the archiving of batch samples. As bars are wrapped and prepared for shipment, dedicated staff routinely pull random samples from each batch, often one every few thousand bars. These samples are sealed, labeled, and logged with all relevant metadata: the exact time of production, line number, raw material codes, chocolate viscosity at time of enrobing, coconut moisture content, and even almond roast profiles. These reference bars are stored in secure, climate-controlled storage units maintained at conditions that mimic ideal shelf environments. The goal is to preserve these products in a stable state for up to 2 years, during which time they may be retrieved for comparison if any quality concerns or deviations arise. In addition to acting as an insurance policy against customer complaints or distributor queries, these archived samples are regularly tested as part of long-term shelf life studies. Trained quality assurance technicians perform controlled aging studies by artificially accelerating the aging process in heated chambers to evaluate how the product will hold up over time. These studies track changes in coconut chewiness, chocolate bloom resistance, almond crunch retention, and overall flavor integrity. Sensory analysis is conducted by expert panels who evaluate sweetness, aroma, textural contrast, and mouthfeel using standardized scoring systems. This data feeds back into ingredient sourcing decisions and packaging refinements, allowing the team to adjust variables well before any potential issues could reach consumers. Now, it's time to go into the digital control systems that operate silently beneath every piece of equipment, coordinating, recording, and adjusting every stage of the Almond Joy production process. At the core of this system is a network of programmable logic controllers, PLCs, which manage the real-time operation of machinery across the factory floor. These industrial computers are programmed to respond to sensor inputs and control outputs with extreme precision, enabling the synchronization of critical events such as syrup dosing, coconut extrusion, chocolate tempering, and wrapper sealing. For example, if the syrup temperature in the blending kettle falls even slightly below the optimal range of 235 to 240 degrees Fahrenheit, the PLC will automatically trigger a compensatory adjustment in steam pressure. Similarly, if a sensor detects that the chocolate curtain in the enrober has begun to thin, indicating an issue with flow rate or chocolate viscosity, the system can alter pump speed, activate an agitator, or send an alert to the line technician. These reactions happen in milliseconds, ensuring seamless operation with minimal human intervention. All this data funnels into a supervisory control and data acquisition system, or SCADA, which acts as the digital nervous system of the plant. SCADA systems provide centralized visualization of every variable in production, from torque readings in the coconut mixes to conveyor belt speeds on the packaging line. Live dashboards display real-time metrics alongside historical trends, and operators can set control limits to trigger alarms, shutoffs, or automatic corrective actions when deviations occur. Data logging is continuous, with every action time-stamped and stored in redundant backups for audit and analytics purposes. But up next is the role of continuous improvement teams and how they use this wealth of production data to fine-tune the manufacturing process. Rather than viewing each shift as a discrete operation, modern Almond Joy factories treat every minute of production as a learning opportunity. Statistical process control specialists and lean manufacturing engineers analyze massive volumes of data to identify small but significant trends. For instance, if there's a subtle uptick in the rate of chocolate flow variation on line 2 during evening shifts, it might suggest thermal drift in the tempering unit or minor calibration errors in the chocolate pump. These insights allow preventive maintenance schedules to be updated, saving time and resources while minimizing the risk of future disruptions. Some adjustments are made on the spot, while others lead to full pilot testing cycles. Pilot lines, scaled-down versions of the full production setup, allow engineers to test adjustments to temperature profiles, mixing durations, or conveyor speeds without interrupting primary operations. For example, if a new batch of coconut arrives with slightly higher fat content than normal, the pilot team may experiment with modified syrup ratios or mixing times to maintain the same moisture binding characteristics. Results are measured using laboratory tools like refractometers, rheometers, and moisture analyzers. And the most successful configuration is then rolled out to full production. The focus on fine-tuning doesn't stop at equipment and ingredients. It also extends to the behavior of the product throughout the supply chain. Some Almond Joy bars are shipped across the country or even internationally, and that means packaging and formulation must perform under a wide range of conditions. Engineers perform transit simulations using vibration tables and thermal chambers to replicate the effects of long-distance trucking or air freight. These simulations allow packaging specialists to evaluate wrapper integrity, seal strength, and chocolate stability under heat and motion stress. In cases where performance can be improved, new materials or layering structures are proposed, often months before the consumer ever sees the final package.